Hello.
Good evening, everybody, and greetings from Broadcast Central, where I hope to have a much better and stronger signal than I did the other night. Again, sorry for our surprise cancellation on what was it? It was Wednesday. Wow, how time flies. But I'm back in the office. So just a quick recap to start things off, since this is only our second lecture. You're not going to be penalized. Again, I'm really sorry for the internet outage the other night. I'm going to have some makeup lab time and office hours tomorrow night. We're going to review a few things and cover where to find everything again. And just a quick heads up, please hold all of your questions for the designated time. I'll designate good Q&A time because I want to make sure that I give you by voice answers and that I don't miss anything going by in the chat window. But I do want to hear from you in the chat window because I haven't seen much yet, aside from thank you, Abdullahi, for the notice about Obata. And I see he is here. I'm about to knight him. Obata, you are a co-host. Thank you again, Mr. Mohammed. Audio check quickly.
Hello, hello.
Can you confirm hearing me, everybody? Just give me a quick heads up. Awesome. Thank you very much. Okay. So again, we're going to do mostly lecture tonight. We're going to do mostly lecture again on Wednesday to try to make up for some of the time that we lost last week. And again, I'm going to have makeup lab time. If this is your first time, if you missed the first lecture, again, please call me Peter. I'm not a doctor. I don't even have a master's degree. I'm no better than anybody. Again, please mute yourself when not talking. Good Zoom rules. Put all of your significant others on stun or vibrate. And again, please hold all of your questions until Q&A time so I make sure that I give you the best answer. Anything you might have missed is in Blackboard and the slagheap.net website. And the reason for slagheap.net will become very apparent later on. It's also a convenience for all of you. I know a lot of you use your web browser as your PDF viewer, and I didn't want you to have to log into Blackboard in order to reload one of the labs if you were reading it in a web browser. Plus some of our materials later, you're really going to need to be able to get at automatically for some of the grading automation later on. So it really just made sense to mirror everything on this website in that hidden directory. So everything will be posted in Blackboard, but those of you who don't have access to Blackboard, worry not. It will also be in Slaggy. The notes may get changed during class and updated. I am going to start trying to post these ahead of time to give you guys, you all a better idea of what I'm going to lecture about. Here's that second location to watch, and everybody on the wait list, I believe, got added. I don't turn everybody away. So again, on the horizon quickly, Lab 3 is going to drop by tomorrow. We're not behind schedule because we got those first 2 labs back. We just have a little bit of lecture and concepts to cover and make up. And again, we're going to try to cover this tomorrow and Wednesday. The pace of the labs will start to taper off a little bit. So if you're still on lab number 1, please don't feel like you're behind by in any way, shape, or form. Lab 1, again, is the most difficult for everybody. My sense is it's less hard this year because a lot of the things that students learned in last year and became errata in the lab, repeated revisions of the lab, got cooked into the lab in its first release to you all this year. So there are going to be fewer lessons learned. It is a little easier, but it's still the hardest. Again, don't feel like you're behind. The pace of the labs will taper off a little bit. We're just trying to get all of this in front of you so that you can work it on your own pace. And if you get ahead of us, outstanding. That'll free up some time to do some other stuff, hopefully. Yeah, again, we're going to polish all of these off and crank them out to you. And I already talked ahead of my own bullets. You can see I don't read it all. I didn't realize that my next 2 bullets were exactly what I was about to talk about. So today, again, all lecture, a little Q&A, no lab time. I'll host a makeup lab time. Let's go ahead and set a time for this right now. I just need it to be after regular business hours. As most of you have probably surmised, teaching at SDSU, though it is my favorite job, it is my part-time job. I have another full-time job, my own company, and it's many clients that pays the mortgage and puts bread on the table. So that's why this class is after hours, and I'm going to be hosting a lot of things and asking you to do office hours with me afterwards. So let's do something from like 5:30 p.m. to like 7:30 p.m.-ish tomorrow night, not too late. And again, we'll do more lab after some lecture on Wednesday. Since I failed last Wednesday to give you reading homework, here's some reading homework. And again, like I said, on the schedule and the syllabus and the Nemeth book, when I say read it, don't read it, just kind of flip through it. Look at the concepts, look at some of the commands, think about these things. Don't hesitate to bring good questions to class, but look through chapters 1 through 5 of Nemeth. Again, Nemeth is more of a reference. It's a great accompaniment to the manual pages in that are built into your operating systems. But if you want to know how to do something in general and you don't feel like starting out with a man page for some reason, Nemeth and the index to Nemeth are a great place to start. Just go there, find the thing that you want to do and see how to do it. Usually here today in the second lecture, we used to do a quick VI demo along with an installation demo, but Obata already handled the install demo, and thank you again for filling in for me, sir. I heard nothing but good reviews. We used to do a quick VI demo. Just by a quick show of hands here, let's try using the show of hands in the participants window. How many of you all would be interested in a VI demo? I'm counting about 10 right now, 11. Okay, the number continues to go up. I think that's enough that we'll probably do something either tomorrow or Wednesday. Go ahead and drop your hand so that we can save it for question and answer time. But I'll go ahead and make a note here. Peter will do something tomorrow, Wednesday, announce by Tuesday a.m. I'll figure out when I'm going to do it by tomorrow. Yeah, I went ahead and hid these comments and had them next because I kind of suspected that it's a whole lot easier to do a demo of something like VI when I have, it's funny, this is one of the places where I actually use the document table camera in all of the smart podiums and the lecture halls at SDSU, because I could show my hands on the keyboard and you could see me as I was doing VI, especially helpful when I'm doing VI with an older or a less fully featured OS and I'm not using the arrow keys, because arrow keys in computing history are actually a relatively new innovation when compared with Unix. And therein lies some of the fun in learning to use VI. It's funny, I saw this meme the other day in the channels of one of my customers about how even though people are seasoned programmers within a place, they still always find themselves watching a YouTube video of a foreign lecturer teaching them about this new API or programming language. And everybody's consensus was, yeah, true that, because we've all been there. And YouTube how-tos are bloody awesome. Again, you can find everything you need on the internet. This is why I'm kind of a pain in the butt if you don't ask good questions, or it's obvious to me you haven't web searched your question, because you can find literally everything out there. I may just do this Wednesday during the lecture because I want to make sure that I don't lose so much. Yeah, I'm going to think a little bit tonight about how to do it well. And heads up, too, I didn't mean to surprise you, Obata. Obata had no idea coming into tonight class that I was going to say, let's do a lab tomorrow night. If you're available, great. If not, no thing, man. I will totally handle it. Thank you for filling in again on Wednesday, sir. Any demo requests, feel free to answer later. Again, this is why I encourage you to look through some of the text, to skim things. If you see something and you don't know if it's going to be covered or you don't see it in the course documents, let me know, please. Let me know with an email. Not right now, not in chat, because I will definitely lose it, not read it. As you can see here in my notes, again, I was planning on giving the top of the lecture last Wednesday to Obata to do the installer demo. I'm glad he got to do it. I have not taken the time to see it here, but I thought now would be an opportune time to do some Q&A, because we're going to continue some demos. I'm going to run this first one kind of loose, and I want to make sure that I'm taking questions as I cover stuff. But today, I'm just going to cover a lot of core Unix concepts. And before I jump into that, I want to make sure I take some Q&A time. So if anybody has any questions, please raise your hand. People? I don't see anybody raising their hand yet. Okay, there's one. Well, it's fresh in my head, though. Again, I know that there's also a backlog of people in my inbox right now. That's all the more reason I wanted to do some bonus makeup time. All right, Mr. Choate, please be heard, sir.
All right. Hey, Peter, I just had a quick question on Lab 2. When I get like automatic emails overnight, I only get emails from FreeBSD. I was just wondering if we're supposed to get it from OpenBSD also.
You definitely should also, and if you completed Lab 2 with the setup done correctly, you should be getting mails from both machines, yes. And if you're not,
I'm sorry.
No, go ahead.
I can send emails from both of them, but I just don't get the auto email from OpenBSD.
That's interesting. You probably just don't have the forwarder set up correctly, or the email alias. And I'm hoping I didn't miss no. I don't think I missed a step. Did I? I don't want to tell you what you might have missed, but I'm going to check. Please do me a favor, Robert, and send me an email.
All right.
But I'll double check to make sure I didn't miss something. Did I answer your question? Anything else? I'll take that as a no. All right, Mr. Phillip, you are up.
Hello, Professor. Peter, sorry.
Okay.
So same thing, same question you just had. I believe you said something to man the, forgot what it was, and read how to input the forwarder, which you have to also apply forwarder true or something like that. I wasn't sure on the exact code I have to put in the file.
So which forwarder are we talking about?
Just the step where you add the forwarder.
Mr. Choate, so I need a little bit of context. I was able to speak to a forwarder in the last question because Mr. Choate was asking about email forwarding. And I've asked you to set up two kinds of forwards. I've asked you to set up email forwards, and I've asked you to set up DNS forwarding servers in case your name server doesn't have a local lookup for something.
Got it. Thanks.
Which one are we talking about?
It's the one with the email.
The one with the email. So you need to edit Etsy mail aliases or Etsy aliases depending upon your operating system.
Yeah.
And there's a command that you need to type as well to tell your computer that you've made changes to that file.
Right. The new aliases, right?
That is correct, sir.
Yeah. And then it runs it. Okay. Thank you.
That was it?
Well, I mean, I did that, but I'm not getting my OpenBSD files. I'm also receiving emails from, like, I can send an email from OpenBSD, but I'm not getting the updates.
You're not getting emails from the cron daemon.
Yeah.
Like the last question.
Yes.
I would definitely look in your log files on your BSD VM and see why not.
Okay. Thank you.
They're going somewhere. They're either going to a mail spool on that system if they're not getting forwarded, or they're getting stuck because of an error of some kind. So you're either going to see mails get locally delivered there into a spool file, and I showed you that directory by design during lab 1 or lab 2, I'm fairly sure. I think it was actually in lab 2 where I said, hey, var mail, just in case. I'll go ahead and put that here. Var mail is your local mail spool on most OSs.
Okay. Thanks.
So yeah, you're either going to see it delivered there, or it's in trying to deliver it, there's going to be an error that you're not seeing it on your OpenBSD, on your FreeBSD mail server.
Okay. Thanks.
Yep, indeed. What Mr. Aziz says, like I said, I'm not going to be reading chat. I want you to ask your questions, but yes, this is what he said right here. Tail-F, var log messages is your best friend. Seriously. If you get into the habit of, this isn't working as intended, I'm going to look at my log files and find an error message, I promise you will be happy in the long run and solve things. Any other questions? I see Nano mentioned. Again, don't use a crutch like Nano. Use VI wherever possible. There's a reason why I'm showing you VI. You'll be able to run into a 30-year-old computer and still know exactly what to do with it, how to configure it, and how to find your way around, and you won't be crippled. Any other questions, people? Okay, I'll take that as a no. So again, we're going to mostly cover core Unix concepts here today. Real local, real loose style. I've got my files here with all my stuff from this class. I've got 4 VMs ready to go, including the upcoming CentOS VM that I haven't released Lab 3 for yet. And I've started up, this system is running Open Indiana, which we'll be setting up in Lab 5, I believe it is, to show you what a commercial Unix looks like, what an old AT&T Unix looks like as well. Hey, Brandon. I said, please, so we just had Q&A time, man. Please hold your comment about getting emails. If this is a question you want answered, save it for Q&A time. If you want a response from me, chat here during class is just not the best way to get it. Okay, again, back on track. 4 VMs, a web browser in case I need it, a couple of shells here. And just a heads up about these handouts. I'm gonna make sure that I post these back both on Blackboard and on Slack, but it's funny, the Nemeth text is one of those things that you keep on the shelf, and it's kind of a time capsule, but I told you all already that I took this class from Dr. Carroll, who still teaches today at SDSU. And when I took it, Nemeth was one of the official texts, and the other was this book of photocopies that he made us go get from CalCopy, which I think has been out of business for a few years because nobody actually physically prints bound materials anymore when they can hand out PDFs. And Carol used to literally lecture directly from these handouts in that book of photocopies and printouts that he made us all buy. And this stuff, I went through it lovingly. A lot of, he still does. That's neat, Zach. I bet he does. Old habits die hard. And indeed, again, the materials that I inherited for this class were largely, again, new operating systems, but the same class that I took early on, which is why I realized I had to, it was time for it to go. But this part I realized had to stay. And I'm going to be giving you all of these handouts about directories, file system layouts. These are the holdouts from Carol's book of photocopies that were still relevant and that you had to see. Now, I'm going to be referencing a lot of these now, but again, we're going to come back to it at the end of lecture, or at least around the end of, let's do it before we talk about booting. I'm going to paste that there as a reminder that we're going to look through the rest of the handouts, because as you will see here in my notes, I reference seeing handout, C handout. You'll see C handout. I'm going to pull some of these handouts in throughout the lecture. And again, I will make sure that they are all posted later. But first, I'm going to show you a few things, and we're going to talk about concepts. Funny dangling thought right there. Again, like I said, I will edit notes during lecture. So, Unix commands. For those of you who are new to it, you've probably noticed that a lot of the very basic commands are really short. For remove, RM, for copy, CP. I mean, we're talking about people who typed for a living. A long time before we ever had a keyboard or a mouse, they wanted the fewest amount of keystrokes possible, literally, to get the job done. I mean, there really was it's funny, there's an old saying about Unix that in response to people saying that Unix is not user-friendly. And the snarky retort to that is that Unix is user-friendly. It's just picky about who its friends are, or what type of people its friends are. It's definitely was designed by a certain kind of person for a certain kind of person. And there definitely was, at least at the beginning, a design philosophy of sorts. And this is somewhat watered down today, as you will see. I'll talk about this again after I lay out some of these concepts. But again, short names, saving as many keystrokes wherever possible. The second one is that every command should really just do one thing, only one thing. And with a lot of the very base commands, you'll see this, that they still do one thing and they do it really well. In order to make them as configurable as possible, what we typically used to do was use letters as switches to turn things on or off. Sometimes in some cases when we want more than just a 0 or a 1, sometimes we would historically use a capital letter to augment an option, say. But you'll see this in commands like on a BSD Unix historically. A lot of the switches, you didn't have to type a dash. And you can see here that I've run PS. This is the process listing. I don't actually know if I think PS is just process. It creates a list of processes, so I don't think S stands for anything else. But the switches I have provided here are to provide processes from all users, to list the usernames, to give extra wide, double, triple wide feedback, essentially to spit out here on each line, as you can see, the entire command that was typed with all of its arguments. The PS command dumps all of the process tables out of the kernel. And as you can readily see here, again, I'm just Peter here. I'm not root. All users are able to see all of the running processes. So you should not have any sensitive information showing in the name of your process. This is worth remembering because you don't want to have, say, a password show up in this PS list. Let's see, and System 5, because these commands often grew up in two different environments, in some cases, we have a set of operating systems that will use one set of switches and another set of operating systems will use a different set of switches. I'm shelling into, this is Sonos, the open source derivative of Solaris. It is an AT&T descended canonical System 5-ish Unix. This derivative is called Open Indiana, so some of you may recognize the Indiana Jones reference here. But in System 5, all switches are typically required to be prepended with this hyphen. Some people will call it a tag. And very much like what I did on my Mac in that prior command window, on this System 5 Unix box, this VM right here, this means that I want to do extended output of all users, and I forget what the F switch is, but let's grep for OS or PS. And not to get ahead of myself, I'll talk about this pipe here in a moment, but you can see the output here is very similar. And again, the same concepts extend. What we have here is a user owning a process. This is the process ID number, the parent process ID number. Let's pipe this through the head command to take the first few lines of the output of PS and display just those. Many of you who've already gone through lab number 1 have seen the tail command, which grabs the end of the file instead. And you'll see this C. Oh boy, I don't know what C means. I'm going to let you all discover what C means by checking out the man page. I've actually never used that field, but here we have a start time. We have a TTY. You have all seen TTYs from editing that TTY configuration file on OpenBSD at the beginning of Lab 1, right after you did the installation. You changed the console from secure to insecure to make sure it requires a password to log in. That console is the physical terminal here of your OpenBSD VM. There's my OpenBSD VM. That is dev console. It is a TTY. The idea here is a TTY is a terminal, and sometimes it's abstracted to be a serial device. Historically, typically these days, it's a network device. For instance, like you can see if you run the who command to see who is logged in, you'll see that Peter is logged in. You'll see my ubiquitous 192.168.223 addressing scheme from all the labs because I'm logged in from my host system, but that I am logged in here on TTY PTS1, the first virtual terminal there over the network via SSH. So again, back to PS, rabbit holes. I'm really prone to rabbit holes, as you can see, but so long as I'm not boring, don't hesitate to say something in chat to kick me out of a rabbit hole. But here you see a start time, the terminal that the process is attached to, the amount of CPU time that has been spent, and again, the full path typically of the executable that has been called, and typically all of its arguments are specified there as well to help you distinguish between multiple instances of a same process. You can see with some of these that the command is not a full path. And in many cases, these processes, especially the ones numbered really low, they're not actual processes in the strictest sense of the word per se. When the kernel boots, and we'll get back to that, what is the kernel? We're gonna talk later about what the boot process looks like on Unix as well. But when the kernel starts up, and it's, again, the core of the OS, just to give you the short explanation now, the first things that it does are to create a mock-up of processes for certain pieces of code internal to the kernel. Like here we have sched. This is the scheduler. This is the piece of code that determines which of these processes gets the next time slice, the next 10 milliseconds of CPU time. KCF PoolD, again, a man in a lot of cases will resolve what this is, or won't in some cases. If you fail with man, we're going to talk about paths a little later and why we might not find the man page. But again, this would be perfectly appropriate to go ahead and stuff into a web browser. And I'm not going to follow the links, but you would be able to find out what KCF PoolD is. zpool, rpool, I know that this is to do with ZFS, the file system. So this is file system handling code. And init, you'll see we'll bring up over and over again, but init is historically in a lot of Unixes always process ID #1. But again, this is a part of the kernel mocked up in disguise to look like a process so that it shows up as a process, can interact with APIs, and so that you can send it signals and handle it like other processes, even though it's a part of the kernel. You can see page out. This is a part of virtual memory in kernel and FS flush file system flush, I'm guessing, but that's a pretty safe bet that that is exactly what it is. So I showed you PS here, show you again, there is a Unix design philosophy, and it's broken down somewhat over time. You can find snarky articles online showing how the average number of configuration switches in a utility went up vastly from like 1970 until 2020. You can see a lot of these too. This I'm wondering which version of tar. If I do man-tar on system 5, it's probably not going to be GNU tar. So let's go to the CentOS VM. I'm going to a Linux by design here to try to get one of the GNU, one of the GPL, the Linuxy versions of the userland utility tar. And you will see what I mean by this paradigm breaking down almost immediately, and that nowadays a lot of commands, they try to do so many things in a lot of cases, and I'm not going to debate whether or not it's merited. I'm just pointing out to you that this was a style and a design paradigm, and it's somewhat broken now today with feature creep and as code grabs new purposes in life. But you can see the dash is typically a convention for a command switch or an argument for a command where the name of the setting is completely spelled out. And you will see this in commands like the ubiquitous tar, which, you know, historically you used to invoke like this in this line that I'm highlighting here. You know, just letters. You can see the old BSD style. You don't have to use a dash. A lot of most OSs nowadays, no matter their genetic history, will tend to honor the syntax nowadays, but this is what it used to be. It used to be fairly simple, and it's not so much anymore. All right, your two best friends here, back to the notes. I just wanted to make sure that I really emphasized and underlined this and showed this to you across a few different OSs really quickly. Unless the manual pages have not been installed in an operating system instance that you're logging into, you should be able to find anything that you're looking for after logging in. And it's really important to point out the goal here again is developing that confidence and knowing, I mean, you don't have to, once you're cozy with a Unix, you can really move to anything else that is Unix-like and find out how to do whatever else you need to do that might be specific for that OS. That crazy, zany, strange old 30-year-old computer in the back corner of the data center that you inherit in your future job, you will know what to do with because it has this common interface and this common concept. It's worth noting that, I don't know if I bring up this word later, so I want to make sure I bring it up now in reference to this, because we have, like I said, Unix, it's not an OS anymore. It's a standard. And you can pay the open group, a standards body, to review your operating system and hold it up against this standard and determine whether or not it is a Unix 2003 or a Unix 1997. I forget what all the various years are as they've adapted the standard. But needless to say, you don't have to pay the standards body and you can just release a piece of software. And this is why most things that are out there that are Unix-like don't call themselves Unix. They call themselves, you know, Unix-like. You may have noticed that in the message of the day by default in OpenBSD. It makes a point of saying, hey, we're not Unix. I think if we, oops, I don't think I changed the Monty, but yeah, you can see it right here. The proactively secure Unix-like OS. They're acknowledging that they're not Unix, and very few of these operating systems actually are. Again, what is still Unix out there today? Apple paid to be measured against this standard. Solaris still is, but it's a dying operating system. You will still see it used a lot in data center applications, which is why it's in this class. IBM has its Unix, and again, we're going to try to use that. IBM hasn't given me any VMs yet. And I think there's Linux in China. A couple of Linuxes have been made, measured against this Unix standard. But by and large, what we expect a Unix or Unix like to have so that we don't call it Unix when it's not. And sadly, unfortunately, because a lot of people get touchy when you use the wrong terms for stuff, as we can see in 2020. We've developed this term POSIX. And POSIX is what we mean generally to have a Unix-alike interface and APIs and functionality. And if you say POSIX, you're generally talking about a Unix or a Unix-alike command line and APIs. And this would create an umbrella if we were to make it a Venn diagram that would have absolutely everything, Linux and Minix and all of the Unix clones and Unixes and BSDs in it. And again, you can find your way around any of them once you know your way around one of them because of this whole general POSIX design or this POSIX philosophy and interface. So again, here on Linux, there's man and there's apropos. And I'm going to do man apropos and see what it says. Search the manual pages. I was just curious if apropos actually had its own man page. And you can see it's relatively short here. And it's got very few options. Well, I spoke too soon. It's actually got quite a few options. But I know of, I threw around man-k because man-k is really all you need to know. And it is roughly equivalent to apropos on most operating systems, such that if I wanted to find things to do, again, with directories here on this machine is CentOS, it's a Linux. How about folder? Really nothing appropriate? Have I not built the man pages here? Apropos folder. Gotta love it when demos don't work. Man-k disk. Nothing appropriate. So long as we're talking about man and man-k, so apropos is the same thing as man-k. And apropos and man-k both read from, I'll put $manpath here. We're going to talk about path name variables here again very shortly, but they will read from all of these directories in your manpath / what is. And this file, what is a database, if you will. I think it's actually just a line-by-line text file of the one-line synopses at the top of every manual page. The name and brief one-line description of every command. So that if you wanted to do a keyword search for all of these, if you knew the command name or a part of it, or a general description of what you were looking for, like the manual, here would be obviously an appropriate word. We were looking for the manual to find apropos or to find man. And all of these one-line synopses would show up. Let's run it here on Solaris, man-k directory. And you can see, like expected. Let's go ahead and pipe this. Again, we're going to talk about pipes as a concept here. And again, I wanted to run this really loose, so you just saw me operating loosely and talking around and narrating what I do on a command line, doing some very common things to show you some basic concepts. And here, the second command that I'm piping the output of man-k directory into, because it was really long, I'm just kind of academically curious how many lines are in it. WC was short for word count. And I believe if you provide no switches, it literally counts the number of words in the input that is provided to it. With the -L switch, it counts the number of lines. And we know there are 91 things in the online man pages for Open Indiana again to deal with directories. How about disks? So this time let's pipe it through more, expecting that there are going to be a bunch of lines. And let's say this is exactly what we were looking for. DF, or maybe DU. Both of these look similar. If we want synopses of disk utilization and free space, both of these look like good commands already from looking at commands relating to the word disk. So I'm going to hit Q here to exit that output again, and I'm going to do man now for DU because I saw DU was a good one. And it summarized disk usage, and we can see the operand is a file. And well-written man pages, you can generally get the idea here immediately just by looking at the synopsis for the command. The operator is a file. We have some switches. I'm going to shortcut through scrolling through this man page. Again, my point here in bringing it up is to show you this is what you should do. But this -H switch makes it human readable. So if I was to say du-sh tilde, and again, tilde, the meta character tilde means my home directory in most modern shells nowadays. So this command, God, what's the S? Sorry, I am going to go ahead and read it because I don't remember what the -S is. But the -H is going to make it human readable. I'll show you what it looks like without human readable on. And -S, instead of the default output, report only the total sum. So I think this is what makes it descend into a directory. But let's try it without. du tilde. Okay, and you can see it's descending into files. And if we do du-s tilde, it does a total of the directory. And if I do, without the human readability, you can see this is 27 megabytes. And we would have to infer or already know that the units here were megabytes, but in a lot of operating systems, the du command is still going to default to kilobytes in a sign of history, and that is a little less readable. So this -H switch, as you'll see with a lot of these disk utilization commands, including ls, is going to spit out file sizes in human readable terms. Like ls-lh, you'll see that I have a core dump here from April 4th that's 16 megabytes big, but most of these directories are very small, as you'll see, just a few bytes a piece. And I'll show you exactly why those are just a few bytes a piece here in a few minutes when we go over the handout for directories and talking about file systems. Okay. Any questions about man or apropos? Inviting hands up before I move on to the next thing. Another dangling thought here. I'm going to go ahead and show you argv. Argv on all shells. This is just one of the places where you see how Unix and C really grew up alongside one another. And the shell is inescapably tied to the language that implements it. So if we have a command, let's do a hypothetical command here, like tar cvf ./home.tar /home Peter. And this command here would use tar to create a tape archive. Now this is just a file nowadays, a lot of the time. This is very analogous to a RAR archive that a lot of you on Windows will have seen a lot of, but this of course predates it. So we are going to create a file verbosely listing all of the files added into the archive, where the file name, the next argument, is ./home.tar, and we want to archive the directory home Peter. So I'm going to cd into temp here on this Solaris box, and I'm going to punch in this command so that you see it. Removing leading slash, and as you saw, my home directory on Solaris by default is not under home, it's under export. So export home Peter, and you can see it listed a bunch of files, and it made a tar archive of roughly the same size. We didn't do any compression here, but roughly the same size as my home directory. Again, du-sh tilde. Just to make sure I show you df. df lists the actual file systems attached to the computer. But back to argv. So argv counts in C like lots of things in computers do. And argv, when handed both to the shell and to a programming language underneath the shell, argv is a part of the environment that's handed off between processes within Unix. And argv is just one of those variables that's set with characteristics that need to be passed from process to process to inherit implementation characteristics, things like paths. And you'll see here, we're going to get into this a little bit more very shortly. Implementation details, working directories, username, where to find commands, and argv. Again, I use hard brackets here as this is a common way of depicting an array, because really this is an array. And again, this will be argv, the array, is the command that we typed on the command line. And let's go ahead and alter this so that it matches what we typed here. So to the shell, this is argv0, the command. So you can always check the variable in your shell or in your code once it gets invoked in Unix by the shell. argv0 is the name of the command that you were called at. We'll see how this is useful. The command you were called at. And we'll talk a little bit more about argv0 before we adjourn. And the arguments, of course, start with argv1 and argv2 and argv3. And again, historically, it was convention that argv1 had all of the switches all in one place, all in one blob, not separated by spaces, and some implementations prepended by a dash. But you could query this array that is handed to you immediately after execution, whether you're a shell script, an interpreted file, or a piece of compiled code running. You can look through the array argv that is handed to you from the second that you are started to read all of the arguments that you were called with. argv0 is really important because we can have a command implement more than one thing that's related. And I'm trying to think of a command that does this commonly. Does anybody know any off the top of their head? Abada, do you know any off the top of your head?
Can you repeat the question? I was trying to do something.
All good. Do you know any commands off the top of your head that reliably perform two functions and have two binary names?
I do not.
Here we go. Here's a good one. So I just grepped for 2, thinking I was going to find it here in the output of ls-l. And you should all at this point in the game have seen the output of ls-l. Again, this is the permissions. Do we need to cover this just quickly in chat? I'm looking at chat now. Do I need to talk about the output of ls-l? No. I see 1 please and 5 no's. So far you are outvoted. Okay. The permissions and file type. This is the owner, the group, the size, the date and time, and the path name, the file name of the file within the directory. You'll see how this is important later, but this number that I skipped over here, and Neil, this is ls-l. This is the long listing of ls output. And this is a link count. I'm going to go over inodes and how this is important, but long story short, this means that 3 things actually point to the same file. And if you do ls-li, I'm getting a little ahead of myself, but a file entity, an actual file system objects are inodes. Not single file names. You can have multiple file names in Unix for the same object, as we will see. So you can have the same binary be installed, but be addressable via various commands. For instance, this zcat. Z is, a lot of encryption schemes call themselves Z for zip. You know, their GZ is GNU zip, BZ is bzip, there's an XZ, there's a PK zip, the standard zip on Windows. But if we do an ls-li here on zcat, this zcat, excuse me, it was user bin zcat. And this is to cat out a file, to concatenate. Cat is short for concatenate, and it just literally blocks things together. Cat this after this after this. And this is a zcat decompresses a compressed blob and prints out the output all in one fell swoop. So if we had a compressed text file, don't hesitate to chime up in chat if you'd like me to show you this practically, because I can literally demo this in a second to show you what it means. I was just trying to find something that had this link count be more than 1 here to show you that when you do ls-l with the I switch, this lists the inode number. This is the actual file system object number of this object, this file that is addressable by the name zcat. If we were to do ls-li for all the files in user bin, and we filter that output for this same inode number, we're probably going to find the other commands that are linked to it. And you'll see that, not surprisingly, very similar functions. Again, we compress or uncompress. And zcat, as I said, by default will decompress and spit out the output of the decompression to the standard output. So this same piece of code is literally addressable by these 3 file names and path names. And it checks when it gets called, hey, was I called as compress or uncompress or zcat, because that changes how it behaves by default. Did I keep everybody with me there? Does that all make sense? This is when I'm looking briefly for feedback in chat. So again, when a shell invokes a process, if you had an operating system You know, we do a fork and exec when we call a new command. And when we do a fork, we literally clone the current active running process. The shell will clone itself. Then it checks and sees if it is the child or the parent. And if it's the child, it runs that new command. But it inherits all of these variables in the environment, so to speak. And yes, Nathan, that's another way of saying it. And I appreciate your paraphrasing it here to make sure the audio track reflects the ask. Nathan Ware says, so the different names are a way of making multiple commands out of a single binary. Yes, absolutely. That's exactly it. So sometimes that one mission, you realize over history, you had two utilities that ended up doing something really similar, and you realized you wanted to make that one blob of code, but have it be accessible by two different command names, each of which declared by default a different behavior. It's worth noting that I do this, as you all probably know at this stage of the game, all of you who are about to have a CS degree, if you don't have one already, I see your question, Andrew. Give me one sec. Wrap. I'm looking through here on my Mac. I have a bunch of binaries in my home directory that are particular to me, just to my user account. And let's grep for egrep for DOS or Unix or Mac. This means we're doing an expression grep, an expression search, and I'm searching for DOS or Unix or Mac. In the list of file names, you'll see these all match here. And I'm surprised because something is broken clearly in my, got broken at some point in cloning this, because all of these are supposed to be the exact same binary. You can see they all have the exact same modification date here and the exact same file size, but this is as I started to say, you're all familiar with how DOS has one way of doing line breaks and Unix has another and Mac has yet another. Mac just uses Control-M, the carriage return. I think DOS uses both carriage return and line feed, and Unix just uses line feed. I may be transposing the last two, but you'll get a text file and it'll have the wrong kind of line breaks for whatever piece of software you're using. So I made my piece of C code to handle all of these different conversions, just be one binary. It would detect which one it's called as, and it would do the appropriate conversion on the input. In fact, I don't think this is too off topic since I'm showing you inodes. Let me answer Andrew's question and then let's go ahead and fix this problem on my Mac, and I'll show you the make file that builds this and what this is supposed to look like, because I bet this happened when I cloned or moved my system. I recently upgraded my Mac, and this is probably when these all stopped being associated with each other. So the inode number of the soft link is different from the inode of the real file. So Andrew, you've got apples and oranges there. You're mixing two different things in a way that I don't feel your question is getting to what you want, because the soft link is completely separate from the real file in a way that a hard link, this link count number that I'm talking about here on the file system, they all are effectively the real file. And I'm sorry if I'm misunderstanding your question, but let's make sure, ask me again or raise your hand in a little bit if I don't fully answer your question. I'm going to go ahead and go to Temp again because it's a great place to do things. And I'm going to untar, if I remember correctly. You can see it's been a while since I touched the source for this. I probably last had to build this when I got rid of PowerPC code a long time ago. The file command is another very, very useful command on all Unixes. it employs a heuristic that is defined in the file. Oh, it's usually an Etsy magic, but there is cool. Glad I answered your question, Andrew. Usually there's a file Etsy magic that creates a bunch of heuristics for the command file, which tries to determine what a file is. And you can see here with the file command at one of those binaries, it shows you that it's a Mach-O universal binary with 2 different CPU architectures. It's got 32-bit Intel code and 64-bit Intel code. This is something that you'll usually only see on a Mac, because Macs use a different binary format to be able to store multiple hardware architectures, binary support in a single file. Linux is usually use other paths for 64-bit binaries and the like. But you can see here that this is a piece of code for both 32 and 64-bit Intel. Again, I'm in /temp because that's a great place to throw a piece of source, and I'm going to tar. Is that no, OS X doesn't have a concept like alternate file streams, Steve. And again, I'll answer questions when I see them in chat if I allow myself to get distracted. But again, please try to hold your questions for Q&A time. I will try to break frequently. All right, so I'm going to unpack the source for this utility. And this almost certainly is, tar ZXVF. I tried to create it rather than extend it. And you can see here I've got a manual page, and I've got DOS to Unix, the C file, and I've got a make file. And if I look at the make file, you will see it's going to make a bunch of links. The program it thinks is called DOS to Unix, but it links itself at DOS to Mac, Unix to DOS, Unix to Mac, Mac to DOS. And the C here, more DOS to Unix / DOS to Unix.c. And you can see this code, by the way. You can see I poached from somebody else, or added stuff maybe from somebody else, since that copyright notice is after mine. But you will see here almost immediately, it's going to check what command name it was called as. Again, argv0. If we were DOS to Mac, then do this. If we were Unix to DOS, do this. If we were Unix to Mac, do that. Just so you can see it again. So those are hard links. Again, Andrew, that was the answer to your question there. I wanted to make sure symbolic links and hard links. We are indeed going to talk about the difference between those two in a little bit. So I'm not going to get ahead of myself. I'm going to go back to where I was at right here. Anybody have any questions on anything so far? So again, we talked briefly about the environment. And one of the huge things in this environment, now I'm going to show you all of my environment here briefly. Print-env is the way to print your environment, both in TCSH and batch. And you can see it's pretty long here. And again, I use TCSH, and I'm showing you TCSH here not to show you something different, but because this is where I actually happen to have my environment completely customized and configured. And you can see I have my SSH agent configured. Some of you have seen this already. This becomes a part of your environment. That's doing what you're doing when you set those variables. Those of you who have done lab 1 and gone through setting your terminal type in single user mode so that you could use VI and the more command. See it here. This is something that is passed as a part of your environment so that a piece of software knows how to draw text within the window. This terminal type defines control characters that are used to display things in boldface and to right align things. As you can see here, my shell, my TCSH, I have configured to show a timestamp as a part of each prompt. But this is how you tell a process and you pass stuff to a process to tell it virtually everything is through this environment, the shell. This is how the shell finds out what it was called as, or how you find out within a script what shell you're being run in, what your the user's home directory is, what their login name is, their effective username. And here you can see the path. And this again is one of these many kinds of paths. Again, to tie it back, I alluded briefly to why you might not see a man page. Well, we create, as we'll see in the Unix file system, in a very fractal-like way, we make recursive subsets of the overall file tree in some subspaces. And we need to include these in our paths if we want to address files, commands, binary software, APIs and libraries and manual pages that are located under these separate install paths on a Unix. These path name variables within our environment are how we store the footprint of the various kinds of software that we want to reference from our shell. So oftentimes we'll change them from time to time, but we'll change them when we install a piece of software and we want to make sure that file tree gets referred to. But we also might customize it for certain runtime environments. Say if we're building a piece of software that depends on a file tree for a programming language like Java, and some of those commands in that Java file tree interfere maybe or override other commands that we typically want to use when running commands interactively in a terminal. We might have a different environment for building software as opposed to running it interactively, for an interactive versus a non-interactive shell. And you can see here, like I said, I have within my home directory, I have a bin directory with things that are just local to my account, as is pretty commonplace. Well, again, we'll talk about the file tree again and go over all these paths and what they look like as a part of the extended hierarchy. But user is where most of the operating system is on a typical Unix. User local is stuff that is only locally installed, so that again you have this fractal-like replica of the subdirectory, but user local is stuff that is only installed on this computer, that doesn't come with your operating system or via its package manager, for instance. Those of you who use Mac, opt is another place like user local. In fact, historically, opt is the System 5 and AT&T alternative for user local. The idea is opt was short for optional, and things that were optionally installed on your computer. On Macs, Mac ports is one way of getting lots of open source third-party software automatically built on your Mac. And this is the path for binaries installed by Mac ports. Opt developer, you can plainly tell this is the development software. This is one of the paths that Xcode puts stuff on. Or actually, funny enough, you can see this is where I've completely customized my environment, because under opt, I aim at a lot of stuff. This is a path under the Xcode application bundle as it is on the Mac. And Andrew asked a question about soft link, and this is a soft link. So you all know it. Again, I'll describe it in more graphic detail later, but this, you can see this is opt. So opt developer, when I say that, it actually retraverses. When I go to this path name, it actually reach reverses the entire file system from the top because of this leading slash and goes all the way to applications xcode.app contents developer user. So whenever I say op developer, I actually mean this, and this is a customization on my part. I didn't want you to review this recording later and go, hey, I've got Xcode installed on my Mac and I don't have an op developer, because I realized that was why. This is a similar customization for the macOS server app, for X Windows, for Unix's graphical environment, because you can install X11 on your Mac. And you can see all these other various paths. You get the idea. These are other places where mostly I've discovered over time Apple has plopped stuff that is hidden, and I end up needing to build things typically. So this is all a part of my interactive shell, including a Plan 9 user land that I've built and compiled here. I think I talked about Plan 9 briefly, the descendant of Unix in our last lecture. Mr. Aziz, since I see your question, briefly, tar ZC, the Z means compress it, and C means create. Excuse me, so creating an archive, compressed. So again, you'll see lots of options here within my environment, including paths that manual pages can be found on. Because as you can see, like these Xcode paths, that there are man pages buried there in the Xcode app bundle that got installed from Apple, but I wanted to be able to address the man pages. And this man path environment variable is precisely how the man command knows where it should look for man pages, and how apropos knows how it should look for what is files. I just wanted to tie this back since I remembered. And so long as I remembered apropos directory, it was, oops, apropos directory, nothing appropriate. So print env, let's see if I set up my man path here on Linux. And indeed I did, a very basic one. Just stuff that came with the operating system and local stuff that may have been built on any particular box. And no, Catman is very clever, Trevor. Catman is actually the command that we use to create this what is database that I referred to, but is probably missing here. So if we look on the CentOS box where we didn't have an apropos database before, user share man what is, it has nothing. So we're going to do sudo. Let's look at the man page for the Catman command, because I recall it requiring a W, but Linux, as you can see here, has no W output. You can specify an alternate man path. You can see it'll refer to a config file, but let's just try sudo catman. And we'll come back here in a sec. Either that or we'll leave it open. And we'll see if it's made that database. Wow, that was quick. No. All right, I'm gonna have to figure out the answer for that. I'm taking an action here. At some point, Peter, find the apropos database on Linux and explain. I'll make sure I release some follow-up notes here explaining why this happened. I'm just not gonna take a total detour and figure out why here. Suffice it to say that you saw that it worked here on this Solaris descended VM and on my Mac. Let's get back to things. So, escaping input, our next Unix concept. So, as we saw in the link of argument variables, argv, the delimiter in between fields of argv is a space, typically on the command line, as we saw here with our tar command, right? And it happens all the time, not just with spaces. For the record, it's really, really poor form to put a space in a file name in Unix. Don't do it. But that said, it happens all the time. And those of us who are Mac users, including Apple themselves, in some parts of the operating system hierarchy, spaces get used all the time. And when you want to make sure that a shell does not process a character in the traditional sense, there are ways of escaping out of it. You can use a single quote, like for instance, let's go into this DOS to Unix. Actually, let's never mind that DOS to Unix directory. I think we got past using that example up well enough. So let's touch file name with a space. And the touch command, as you'll see, will create, I'm positive this file didn't exist previously. And you'll see that file name with a space got created. And you will also see here when I ls-l it that in most cases, the single and the double quote, that was a single quote, and was that a backtick? There we go. I have to use the same single quote in both places, otherwise it doesn't work. But you can see here that in most cases, the single and the double quote on the command line are functionally equivalent to one another. They really only come into play when you want to nest things with quotes, because these things do come up, where you will want to nest something and make sure that a space doesn't get interpreted by the shell inside, or by a command inside something in a quote. You may want to pass something in quotes to the command inside something in quotes, if that all makes sense. But we also have this thing called a backslash, and you'll see that a backslash, by convention, escapes out of the meaning of a character, or the typical meaning of a character that comes after, such that I can also do a backslash here in front of the space, and it will not interpret the space as a space, if that makes sense. All of these backslashes get parsed out by the shell before passing the input to ls-l, but it flags this -l as argv1. It ignores the spaces, and all of this file name with a space becomes a part of argv2, so that we know how to ls-l on the right file. Because again, if we were to do this without space, without any sort of escaping those spaces on the shell command line, it would think we were talking about 4 different file names here. That makes sense? So in a lot of cases, it's worth noting, this is how, if we want to pass an asterisk to a command. See, if we ordinarily, let's say, if we wanted to ls-l file star, that will match everything that starts with the character's file. And you'll see we get the same test file that we've been using here. But this is a Mac, and let's say hypothetically it was Unix, and, or excuse me, hypothetically it was CentOS, which you're about to see in Lab 3, and we were going to use Yum, or now in CentOS 8, it's DNF. And we wanted DNF to install all packages matching OpenSSH. One way to do that is to send the wildcard the asterisk onto that command. But if you do this on a command line with this asterisk here, you're going to see that even though I believe here on my Mac, it's going to say, hey, I don't think it's even going to make it to DNF isn't found, because it's going to try to expand OpenSSH. And here in my temp directory, sudo no match. Yeah, it's complaining here that there's nothing that matches OpenSSH star. What I'm saying here is the shell is trying to expand and match file names matching this. If we wanted to make pass DNF that asterisk, we would put a backslash right in front of it, and the asterisk would be passed to it again as part of arg0, 1, 2, as a part of argv3. And DNF, like a lot of utilities will, treats asterisk as a wildcard for some of its predicates and arguments. And it would look for all packages matching OpenSSH star. Make sense? Did I keep everybody with me? Sometimes you want to pass a backslash. And sometimes you have to use a backslash to make sure that your backslash gets to the command that's called. Because backslash itself is a special character. And again, I think we covered it. Tilde is your home directory. This used to be a C shell only thing, but pretty much everything nowadays honors it. So you could have a file that has the name tilde in it. So let's touch tilde file name, and you'll see immediately that this is interpreted to mean something completely different. And it's going to try to look for the directory of a user. So again, tilde Peter is Peter's home dir. Tilde u user home dir. You get the idea. It means something special. If I wanted to make a file here in /temp that began with a tilde, this would probably work. And I'm going to get ahead of myself a little bit, and you're going to see this neat handy dandy history substitution. Bang $ means the last operand of the prior command. That is the last thing in the array argv for the prior command. And you see that it substituted that here on this line for the last argument of that touch command. But you can see here it went ahead and grabbed that, and we have a file that is named tilde file name. And you can see that LS also put this in single quotes, so you can use copy and paste here. Because I believe the single quote, where one of the places where it's subtly different, is it evades enclosed meta characters. So if you put things inside a single quote, it escapes the input inside of it. That was the functional difference I was missing. A double quote still allows you to evaluate variables, because it's worth noting, you know, $sign is what is of course used to refer to shell variables in a path name, so that if we echo $sign path, for instance, it spits out our path. If we echo $sign argv, how do we make that work? argv0, argv1, subscript out of range. I'll cook up an example for this. I'm going to take another Peter action, ** Peter, do an argv example. All right, and let's move right along. All right, input and output redirection. So it's a known and established standard in Unix that if you don't supply a file name, if you don't supply a file name argument to a command that works on an input that it is reading from the standard input. And we'll see how this is useful again in just a little bit when we get into pipes. But the typically standard in is keyboard from a terminal, but this can of course be redirected to come from a file or another source. Standard out, and this again is another place. I'm going to note it here. Another place C and Unix are joined at the hip like Siamese twins, because this is the file descriptor table and how the shell shows file descriptors, or how user input interacts with the file descriptors that are implemented in Unix. Every open process in Unix has a database within it of handles to open file objects. And the first is always standard in. And it's always item number 0 for those of you who have done C. And standard out is always 1, and this is standard output. So the output of your command goes to this file descriptor. And though they're often the same, especially when you're on a terminal, there is a special file descriptor that is made so that we can send error output optionally to a separate place in file descriptor number 2. So that if we wanted to send error, a standard output to this file, but make sure that error output still showed in the terminal so that we knew that something was going wrong in the case of a really long running command, for instance, we could see the error output right away. We could have that go to a different place. So we can do all of these things, with all sorts of things, with redirecting these things to files. I'm going to go ahead and pull up a page here in a minute that shows how you do this typically in Bash, because Bash inherits its redirection from the old Unix shells. And this is a place where CSH and TCSH fall flat, and why I tell you not to use these shells. Because if you end up scripting things in CSH, one of the funniest rants or diatribes on this was to a mailing list, and it's called, I think, something like ways that CSH scripting can be harmful. And one of the ways is if you're doing any kind of complicated tasks, you really can't manipulate this file direction in really advanced ways with CSH and TCSH. You need a canonical SH to do it, and a lot of system level tasks will require you to do this. Please pardon my back scratching. Best tool ever, the $1 Amazon back scratcher bundle of 5. I highly recommend it. I have one everywhere. And I forgot my drink tie-ins. Today's lecture, again, is sort of sponsored. Your entertainment value. Again, this isn't a real corporate tie-in. I just have a routine that I use to cook my lectures. I always have candy and energy drinks and nothing to eat so that I don't have a full stomach, and I'm hopefully not boring. But tonight is Midnight Grape, Mountain Dew energy drink, and Original Spree and Sweet Tarts. Some more of that right now. The no wine tonight. A later part of this lecture may be sponsored by some kind of alcohol if I'm feeling daring and I turn the record button off. I'm just not going to record a lecture with alcohol involved. That sounds like an all-around bad idea. All right, back on topic. Trevor, Catman is just catting all of the man pages to make that database, I thought. Okay, double. There are other redirection commands. that we can use that are generally honored by every shell. For instance, that command, that caret right here, this means take input from the file listed after. So that means file comes in from the file named input.txt. This means output.txt. But again, then this is where Unix really excels at doing complicated tasks on a command line in a way that you really can't do with a lot of other operating systems. We already covered the environment. So let me come back to input redirection here. And again, I'm going to put a reminder here for myself. Pull up page with bash standard out and error redirection. And I'm going to provide you a link because I want to show you this. I don't remember them off the top of my head. Sadly, this is what happens. And this is why I recommend you don't get stuck learning a CSH or a TCSH, because it's been home to me now for almost 30 years. And I only remember its ways of doing it. And even though I've written scripts in SH and bash repeatedly, what I remember off the top of my head are all the CSH stuff. But so we'll often want to do things on the command line in different ways, as you'll see. The ampersand character on a command line means, hey, go ahead and run this command in the background. Let me think of something really big. I want to make something take a really long time. And I don't want to use up a bunch of disk space in the process either. Screw it. CD, home, doc, SDSU, VMs, CS470. You can see where I store my VMs here. So let's say, again, you've seen tar now. We want to create an archive. And I showed you the V. I will oftentimes, if I want to see a list of the files going by, to make sure that tar is behaving as intended, V makes it spit all of the file names back to standard output as it's creating the archive. So let's create temp/vms .tar / just /. Like I said, dot is the current directory. So it's going to tar up the CS470 directory of my VMs into the archive file in /temp. Now, again, that's how I typically run it. Again, the Z does compression. The C is create. I'm going to drop V because I don't want it to list all of those files. I'm going to run this command in the background, and I don't want it to tell me everything it's doing. So again, you specify the ampersand at the end of the command line, and this tells it, go run that command and give me back another command line. And you can see right here, it's referenced a job number 1 that is process ID 91051. So if I do psaux looking through the process tables and searching for 91051, you see that tar command that I ran. It's showing me the process ID of that command that I just spawned. I can also refer to this. So you saw it gave us command line already. We can use jobs to query the jobs that are running. And it shows the number 1 is still running. The first time that we pressed return, after it stopped for any reason, it's going to report back to us in this fashion. Job number 1, stopped, finished, done. Whatever the status is, it's going to show right here, and the command again for context. But Getting a little ahead of myself, kill is one of the commands that we use to send to process signals. And within the shell, percent means a job number, and kill %1, this syntax is honored by Bash, says that we're sending the kill signal by default to that process. And you see that the kill command ended, and like I said, the next time I press return, it shows that job number 1 was terminated because I sent it the kill signal and it died. What if you get errors in the process, but it's running in the background? Good question, Mr. Aziz. It is going to display that text right over the top of whatever you are doing, which is why you often want to redirect it. Or you may want it just to print it out in the middle of what you're doing because you're not doing anything super important. I think at the beginning of lab number 2, it was really common for FreeBSD to get some of these kernel log messages spit out to the console right as it drew the first menu of the text-based UI for the installer. And I showed you that Control L was a common hotkey for redrawing the terminal window there at the beginning of lab number 2. And this is exactly what it'll look like, where a non sequitur piece of output from another process is going to show up right on top of what you're doing. I mean, if you're in a VI window, it's not going to care. It's going to print it right there. That's one more reason why I showed you Control L, because VI will honor Control L and it'll redraw it and it'll get the spurious error messages out of your way, but those error messages will pop right up. So this terminated, and you'll see because it died, we still have a temp vms.tar that it had already created a pretty large file, even despite compressing. So I'm going to go ahead and remove it. And you can see here again, repeatedly, over and over again. I know I'm getting ahead of myself, but this lecture is precisely for these sorts of things. Bang $ is the last argument of the prior command. So I keep referring to /temp/vms.tar with this bang $ in a series of commands. Mr. Aziz, a tar is kind of like a zip file. A tar file is not compressed in and of itself, which is why in Unix land, we typically make a tar of things and then we compress it. And you'll see things with an ending like .tar.gz. It's nested file type endings so that you have a compressed .tar, and it tells you the type of compression that was used as a part of the file name. So again, semicolon is the background as we just saw, and I showed you here also jobs and percent as a meta character. Chaining, if we just want to do one command after another, we can do ls-l cd/tab. Dang, did our file with the space go away? ls-l pipe grep space. It must have. So let's say we want to touch file name, and then we want to ls-l file name, and then we want to have file tell us what file name is. You will see that it made the file, which didn't exist. You probably noticed I was looking for anything that started with file a couple command lines ago, and I didn't get it. So this first command created the file of a size 0 file. The evidence, you can see the matching timestamp here. Then we did ls-l on it, and then we did file on that file name, and you can see file name is an empty file. It's got literally nothing in it, but we ran this series of commands one after the other, regardless of status. Where is this important? Because we have status operators. We can use logical operators on the command line. And I do this a lot of the time when I want to chain things. For instance, let's say I want to, let's see, I'm going to cook a test case here. Let's echo test into file name. As we've seen, this is going to take, this echo is a shell built in, which is going to print out the word test. In fact, let's go ahead and start just chaining these things together. Echo test prints out test. Now we're going to take test and we're going to stuff it into file one. File one. ASCII text. If we do more file one, we see it says text. If we cat file one, roughly similar, again, it prints test out. If we do chmod 000 file one, thinking about my test case here, I want a test case that is going to fail. And cat file one, and actually let's do this. Let's just chmod it so I can show you the difference. And then cat file one and ls-l file one. So this ampersand means these are two commands effectively. It tells the shell when it's parsing here, hey, everything you've got before it, go ahead and run this. So it's going to run that chmod. And you should have seen chmod already in some capability. This changes again the file system permissions here for a file. And 000 is going to remove all permissions to do everything for even the owner of the file. So that when I try to cat out to read the contents of the file, this command should fail. And it should return to the shell that it exited with a non-zero status code, that it exited with an error. This ampersand means run this next command. Go ahead and run the one before it. Run this cat, but run the next one if and only if the command that came before succeeded. So it's really using a logical operator. Though we're using a logical and here means if this succeeds, then you do this too. And what I think is going to happen is because this is going to fail, we have just denied ourselves permissions to read this file. It's not going to run ls and show us the permissions on the file. And you can see here, indeed, cat complained permission was denied to read the file. And the shell, noticing that that cat failed, never ran the ls command, because there's nothing to stop us from running ls and seeing that we have no permission from this on this file. We own it, so of course we can change it back. And again, if we chmod 400 it so that we can read it, now we can cat it again and the contents are still there. But again, I wanted to show you these logical operators. I've never actually used an OR on the command line, but I have seen it used. And I can't think of a good context in which to use it. My head is only full of use cases like this, where you want to chain a couple of simple commands together, but you only want to run the second one after the first one turns out successful. That makes sense. And you can chain just like you would chain commands with a semicolon. You can chain them with ampersand, ampersand. And I routinely do this all the time. So these are ways of doing chained execution. And I saw your question there, Pocky, and I'm ignoring it now, not only because I already answered it, but because I'm about to talk about it here in a second. Backticks. Backticks are a way of embedding execution within a command. So there's another shell built in with a lot of shells. I'm curious if Bash has it. Let's see. This is Bash on my Mac again here. And let's say which PS command am I running? And this essentially is a shell built in that says, hey, within your path, which PS command are we running if we just say PS? And it returns the full path. So I show you this because it gives us a great use case for backticks. If we wanted to list which command we were running, these backticks, and this backtick again is the backward single quote that is below the tilde character on most US keyboards in the upper left-hand corner, directly below your escape key or the touch bar if you have one of those god-awful MacBook Pros from 16 to 18. I don't envy you. I just ditched mine. But what these backticks do is it says, run this command first and take the output of that command and put it there in the command line. So what this command is going to do is it's going to, I believe, do ls-l bin ps. And let's confirm that. Indeed, it does do that, and that's because it saw this backtick, and it went ahead and forked itself and started parsing tokens there, ran that command and put the output of this which PS command back here onto the command line. Why doesn't that work? Because that's a decent question, and I still wish you'd ask me again when Q&A time came in. But that less than sign there on your sample command line there in chat, Mr. Aziz, it expects a file name as an argument. And there again, you've used two arguments, which and PS. So it's going to do which, and it's going to think that you want to pull input from a file named which, and then it's not going to know what to do with that PS that you've got there. Answer your question? I know it answered your question. Moving right along. All right, history. So I believe I put this at the back of lab number 0. And again, I just want to provide context here. Yes. This was the screenshot from Wikipedia on the last page of lab 0, because this stuff is all really cool and can really save you a bunch of time, especially once you make yourself at home in Unix and you set up your shell prompt. As you're going to notice a few characteristics of my command line here. Again, this is Bash. And by default, Bash says which user you're logged in as, the host name you're logged in as is a colon, and the directory, and it shortens my home directory to tilde. And see here, I've logged in as a separate user that has Bash as its shell because, like I said, I use TCSH. Some of you noted that I've always, since the beginning of time, used UID 666. It's just a joke. Just a joke. But what was I doing? Space, sorry, here on my own shell, where I have thoroughly customized my environment. You can see I do the same thing, and this is fairly common to provide a host name, colon, a path where you're located, where the shell currently is. If we do print working directory, I'm in temp. It shows this on the command line for ease of copy and paste, because as you've seen with SCP, the notation that we use to grab a file or directory from a remote host is host name : path at the remote system. And this is here so that I can easily snag it and put it in another terminal to copy and paste and find the location that I'm on another system. But having this also tells me immediately where I'm at. I know I'm on my Mac, Shoggoth, and I know I'm in /temp. I put a vertical bar here because it's not used for many other things. And you can see that with each command here, the TCSH is incrementing this number. And this is so that I can refer to specific commands. For instance, if I wanted to go back to that file that I was using over and over again in commands, it looks like 17 through 23, but it's no longer bang $, I can say ls-l bang $22, and that means the last argument of command number 22. Or going along with argv, and remember argv starts from 0. I believe we can do, so let me show you that. Again, that is of course file 1, the final argument of command number 22. And I believe we can echo bang 20 : 0, which should be argument number 0 from command number 20. And I believe it's going to print cat, and boom, there you go. It echoed cat as anticipated. But I use very few of these substitutions with regularity. Really, I use bang $ a lot and this notation to grab a argument out of recent visible or easily scroll backable history. Note that there's also the history command within your shell for spelling out all of these commands, and you can see a lot of the commands that I've specified on the command line and giving a lot of these demos here, right up to history, along with timestamps, so that you can look for it, or you can pipe it into grep. And again, if you want to see more of these, I highly recommend that you go through this last page, because there's so bloody many of them that some of them are very useful. I end up using some of them, grep alias ~/.cshrc, and you will see, for instance here, again, bash uses and has taken this whole notation for history substitution from CSH and TCSH. So all of this will transfer to TCSH, but aliases are built-in commands that you create within your shell. And for instance, I have created an eject command here to unmount file systems from my Mac. And you can see here it pulls this, it escapes out of the history command so that it doesn't try to do the history substitution immediately when I run this eject. Eject takes the current running command and all of its arguments, and this alias stuffs it, all those arguments, to this eject command at the end of diskutil eject. Make sense? So just a handy way for me not to type diskutil to invoke Apple's disk manipulation utility on a Mac OS command line when I'm ejecting like a flash drive, for instance. But that kind of brings us, as you've seen here, and you've seen here in some of my aliases, and you saw in that prior example, and I was saying you could pipe history through grep, and grep for cat, for instance, and see all of the history, all of the command lines that had matched cat somewhere on it. But chaining commands, we get to this concept of pipes. And this is a really clever abstraction that the designers of Unix developed soon after developing the first shell, as they realized the geez, it'd be really handy. Never mind all of these greater than and less than symbols. Let's use the vertical bar here. And what the vertical bar means is that standard out from history becomes standard in for grep. For whatever happens in the output of the command before the pipe character, this is affectionately referred to as a pipe, and it's worth mentioning in the same context that you will hear Unix people refer to the exclamation point as a bang, because we've heard it a lot and because it's a whole lot quicker than exclamation point. But the pipe character here, the vertical bar, takes, again, standard output of the prior command and pumps it into standard input of the trailing command. And this becomes very useful because you can chain a series of commands together to do something very useful. Like, let's say here in our shell, you can see we can use history substitution to reference an argument number. And I am going to pull this up again because I thought of a great way to do this. We're going to make an alias. We're going to make alias pfind. Call it PID. Is there a PID command? No, there's no PID command. So a lot of the time we use PID on Unix to refer to the process ID of a running process. So let's actually make this alias UPID. And we're going to make this alias, you can see we use single quotes to define it, an alias. I believe the syntax is the same on bash. But we are going to run ps-aux-ww, and we're going to grep for, now note that grep, God, okay, so this is what web search is for rather than wondering. I know that the RE in grep is short for regular expression because 90% of the time I and most people are just providing a string to search for in grep, but you can provide some more meaningful meta characters to grep. For instance, we want to make sure that the token begins the line or ends the line. And these special characters, and again, look up regular expressions for a good definition of what all of these are, but the caret means that this token we're searching for begins the line. Grep meaning. Original author, Ken Thompson, not surprising. Grep was written overnight. Global regular expression print matching. Thank you very much, Mr. Ware. I'm glad you found that. And you can see here it mentions irrevocably ingraining Thompson's tools philosophy in Unix with minimizing the number of keystrokes. You can see, and grep became a verb all its own, an action verb all its own to do pattern matching with or without regular expressions in Unix, thanks to Mr. Thompson. But again, this caret is one way we can do a match, and we want to match on the argument. So let me define this command. I'm going to do an alias. I'm going to define what I'm doing here. So UPID takes a username as an argument, and we are going to search for all processes owned by that user and spit out all of their process ID numbers. And we're going to use a linked chain of commands separated by pipes. You'll see why this is a good example rather rapidly as we chain the output of one command to another to perform the next task on our output and turn what could be a rather, wouldn't be a huge programming task, but it's something that you can easily replicate with a script on a Unix command line because we have these pipes. So again, I'm going to pull up, I'm going to start authoring it right here so that I can just copy and paste it into the terminal. But grep alias /CSHRC. And again, it's enclosed in single quotes. So if we say that we're going to go ahead and mirror this by developing the command as we develop the alias here in our notes. But let's grep for all things matching the username Peter, for instance. And you'll note here, typically when I've used grep in the past, like here to look for aliases in my CSHRC, my CSH setup file or TCSH setup file, I'm usually providing a file name. But if I don't provide a file name in this tools philosophy, it's just going to read out of standard input. So some of you have noticed I've already helped a person or two who typed a grep and accidentally didn't provide a space between argument number 1, again, the first is 0, and argument number 2, and grep didn't know what to do. It thought it just had one token that it was searching for, and it didn't return another command line because note how this whole standard input principle comes into play if I do grep _Peter and I don't provide a file name, you'll see I don't get a command prompt back, and I can type stuff into standard input. Again, standard input is the terminal, and you'll note that if I type Peter blah blah blah, it's going to repeat that line because it matched this regular expression. It starts with Peter, so it spit that out twice. And if I type in something else, it doesn't match it, so it doesn't spit it out. But Peter is juvenile and obnoxious, as is often said about me. It's going to spit out because, again, it matches this regular expression. But back to our alias again. PSAUX dub pipe grep _Peter, again specifying no file name because we're taking our input from the output of the entire process table in full format. And you will see that every line of this output begins just like our pattern matching before with Peter. So we're searching for all the processes on this Mac here owned by the user Peter. So this is going to be our username. And the only place, so I saw we had to, replicating what I have here, rather than star, we're going to do :1 because we're only taking one argument. And again, let's look at our reference and star : bang :1. That should be the nth argument. So this should, let's do this. In fact, let's go ahead and set this. You may have noted here, this Mac application is helpfully turning my single quotes here into the frilly directional end quote. I'm hitting the undo character to undo that manual change to make sure that this quote matches this one. Note to all users, you always have to look out copying and pasting out of things like PDF readers and web browsers and text editors into your shell command line, because where they do things like word processing and make substitutions like this, they may alter some of your characters. So again, we have now a list of all the processes owned by this user, Peter. There's also this command called cut on most Unixes, and cut is exactly what it says. It takes a whole bunch of lines of input and it's going to slice them up based upon some inputs. Simply, D is a delimiting character. And typically here, again, these hard brackets mean that a argument is optional. So again, if you don't specify a file, or you can specify a list of files, but if you don't specify one, cut, like everything else, is going to pull from standard input. And F here is a field number. So let's do cut -F2 and see what happens. Again, in our PS output here, we really want this second field. Again, I'm trying to list all the process ID numbers that occur from the provided username. So let's cut -F2. And you can see that didn't work. And it didn't work because we probably didn't specify the right delimiter. And this gives us a perfect use case to showcase the backslash again. We want the delimiter character that is noted by cut. And dang, I have to scroll back a ways here to get back to that man output. Let's just pull it again. Up again, man cut. Ooh, this is interesting. So D actually, in this case, in BSD, expects a space between it. On CentOS, if I do man cut, you'll see that it accepts, like a lot of GNU utils, the double dash spelled out version. Let's go to AT&T Unix and see man cut. Dang, and it's funny, none of these are doing the syntax I was expecting. Typically, I was expecting historically -D expects, as you can see here, to be on its own. It's not with -S and -F in that argv #1 spot here with all of the switches, because it's specifying it has -D has an argument of its own, the delimiter. And historically, that delimiter has usually been right after the D. So you'll see a lot of cut commands will accept this syntax, where I would note that I've done a backslash and a space here. You can see my cursor here, a character later, because I've actually typed a space, and it actually is a part of the command line. It goes right after that D and is a part of argv 1, 2, 3 for that cut command. And when we do that, oh boy, we get nothing. So what we're looking at is maybe Peter picked a bad example, or maybe this is a tab character. Let's see, cut -F1, cut -F0, and just meddle around with things is always good. Let's see how we get cut to use tabs. And here I'm in the man page and note that we're allowed to use regular expressions, and / is a search in regular expressions. So I'm looking for tab, and that's funny, D delim. Use delim as the field character instead of the tab character. So the default is tab. I was wrong. Oh God, this is, and I probably did pick a bad example, because that means that these are probably all spaces. How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's just try something. Let's Stranger things have worked. If there are 11 spaces, there is field number 12, the process ID. No, how about 11? How about 10? Yes, counting with Peter. For those of you who remember Sesame Street, 9 spaces. Still nothing. Crap. I don't like giving up. Cut that chef 8. How about that chef 2? If I pick a saner number, how about that chef 1? Okay, that's Peter. How about 13? Oh, bingo, Peter. Okay, so because they all start with Peter, you see that we've got a lot of spaces apparently, and that's strange. But that gives us another opportunity to stick another pipe in here to make sure that we filter out the empty lines. How about that action? So again, we found that field number 13 is our secret sauce here. So let's add this to our alias, cut dash F13 dash D back slash the space. And it's important that we provide that space here. Note that we may need to come back and provide another backslash since we want to actually provide that backslash upstream. Now let's see, how do we filter out empty lines? I don't actually have a command that typically does this at the top of my head. grep filter out empty lines. Hallelujah. Yeah, oops. Grep dot file. Really? That's it? Let's test it. Grep dot or grep dash b dot. Nope. Now we have no process IDs. So that was not the right answer. We really want to do it in sed. So worth noting, Stack Overflow is awesome. That has a Stack Exchange and a number of websites. And again, you can see here, I wanted to do this very loose and very off the cuff and cook exercises out of the blue to show you that I am doing this even after 30 years on a command line all the time to find the things that I need. Because this is what I'm expecting you to do, and it's why I'm going to make fun of you if you ask bad questions. Sed and awk are really old Unix commands. Let's try this awk command. Awk slash dot slash. Let's see if that works. That killed everything. How do I remove all of the empty new lines? Let's try this one. I'm down with that. Nope. Oh. Sorry, user error. It happens all the time, even the best of us. I just realized looking back here that we missed our field number. And there we go. Indeed, grep dot did work, provided we provide the field number. So we want to grep for dot. That filters out the empty lines. And the output of this is exactly what we wanted. Now you can see it provided here as a simple chain of commands interactively provided on a command line, but I've piped the input and output of 4 commands together to say, hey, I want to find all of the process IDs belonging to the username Peter. If you went through the process tables on my Mac, you would see that these match. Did I keep everybody with me here for that? Yes, Mr. Petros. TR is your friend too. The TR command, I highly recommend man TR. TR is short for translate. And you can provide it short commands for changing one set of characters in a provided set of input. Be a standard in or a file name gets changed to a different set of characters in a standard transformation. A real common thing that you'll want to do is make everything uppercase or lowercase with a TR command, for instance. Does anybody have any questions? It feels like it's about time for a little break. I can't quite believe we've already gone 2 hours and 20 minutes. But I feel like I haven't bored and like it's flowed. Please don't hesitate to let me know if it sucked. But anybody got any questions? Show of hands, any questions? Going once, going twice. All right. You can have Catman Comics, Trevor, but I'm taking an intermission, everybody. I'm going to pause recording. And my clock says 8:21. Let's resume at 8:30 on the nose in 9 minutes. I'm pausing recording. All right, I've just resumed recording. I didn't realize I was a minute behind schedule there. Sorry, everybody. You should be able to see my primary screen again. And so long as we're getting kicked back up, anybody got any questions? I see no raised hands, so moving right along past the intermission. Oh, yes, we've got a question. Shocker, it's Neil Bissonette. Be heard, Neil.
Yeah, I just have a kind of a generic question. So the man on inside our Unix for OpenBSD, if we go to the web browser, let's say we don't have our VM up, is that the same thing or not?
It could be the same thing. It could be something different.
From the same company, I mean, and from the same manufacturer.
So man the command on a command line is not a web browser, is not a search engine.
Well, I know, but if I go to, like if I go man pages open BSD in a web browser.
If you find a copy of OpenBSD's man pages online, then that is based upon, herein lies me being a security guy. Just because something is what it claims to be, does that mean it's it? It probably is. There's no reason for that website to be claim to be the OpenBSD manual, but not be. But worth noting, the OpenBSD manual is a set of documents that are in motion. I mean, you really have an apples and oranges question there, Neil.
Okay.
Different things. Web pages be not the man pages, which is why I did an eye roll at first. Anything else, sir? I'll take that as a no. Anybody else? All right, I saw. If you have a question, you can raise your hand, dude. Go to the participants lists. Dr. Henke asked to unmute. Steve Henke, you have been invited to unmute since you can't find the hand raise button.
Yeah, I have no idea how that works. So can you have two shells remoted to the same machine? One shell is doing your command and the other shell is showing the output of that?
Could you make that work? Almost certainly, yes. But why would you? I mean, why would you want to? Given the right use case, sure.
So
in a lot of cases, yes. Actually, I do this quite frequently where I'm running the command in one window. I'm watching to see if there's any error output there. I'm stuffing standard out into a file. And in another SSH session, I'm tail-fing that file so that I can use it as a progress indicator of sorts, which file name it's on. So is it possible? Yeah, absolutely. Did I answer your question?
Yes, because it's that exact, because you were talking about leaving the virtual machine up and visible so you could see the output of errors and such while you were connected via shell.
Leaving the virtual machine invisible?
No, leaving the virtual machine visible so you could watch the output on the virtual machine, on the VM of errors and such while you were connected to the shell.
Sometimes errors do go to console depending upon the kind of error. That is typically why I leave these open. Yeah, I hear it, excuse me, in my CentOS VM, for instance, you can see that it shows a NIC up down message here. I mean, yeah, you do it sometimes, but more often than not, most of what we end up doing is in SSH. When we initially stand up a box and bring it online, whether it's a VM or a physical machine instance, we'll be involved with the physical console typically then and during maintenance-ish tasks. The rest of the time, pretty generally, SSH is more than adequate. I mean, that tar command, for instance, this is something I do rather frequently. I went to HomeDoc, SDSU, VMs, CS470 for this class, and I did a tar CVF temp vms.tar./ and I'm going to send the output of that, as I often do, to vms.tar.out. And I went back and put in that lowercase s to make sure it matched the initial part of the file name there. But you'll see the output is being put into that file. And now if I tail-f temp /vms.tar.out. Wow, that must be standard error. So let's do this again. Note I'm still running tail-f there. Now adding this with the double caret, this is an important thing. I'm really glad you had me bring it up. I'm going to go ahead and make sure that I add this in for input and output redirection. That appends. This erases and starts the target file from scratch. Very important distinction. If you use one redirector, that will wipe the file and start it from 0. And this tail command that I was running here in this other terminal, note these are both Shoggoth. This is both my local Mac here. This, oh crap, I did not want to copy that. That's gonna hork my terminal up. Okay. This right arrow, less than or greater than means append it to the existing file. So this tail should still be good. And it's worth noting that this ampersand bang is the TCSH way of sending standard error and standard out into that file. So now if I do that over here in this tail, you're gonna see the output of that tar command. Is this kind of the use case you were thinking of, Steve? And it looks like I lost you. I'm asking you to unmute again.
Yes, I was on the wrong button. Yes, it does. Thank you.
Yes, so you totally can do this. And there are use cases where you want to do this. And I'm gonna rm temp vms.tar star. We don't need either of them. And I don't need 2 command lines on ShotAuth. I just need 1. Good question, though. Anybody else? Anything else? I see no more raised hands. So let's go ahead and jump into the next concept. It's worth noting that this is, of course, software licensing is not specific to Unix. This is something that affects all software, but in Unix and Unix-like operating systems, a lot of them are varying degrees of open source, and a lot of design decisions are often made predicated based upon the software license of the product that we want to release. So I wanted to address all of these because again, as you'll see here, I talked about GNU. GNU, as some of you may know, is kind of Linux. BSD is Berkeley. And then, of course, there's commercial software, commercial and closed source software, which is worth mentioning here. Closed source or limited license, as the case may be. But you may note that in looking over this tree that operating systems directly correspond to the kinds of licensing options that you have. Depending upon who you ask or whose museum you're going to or whose write-up of the history of Unix you go to, the GPL is irrevocably intertwined with a man named Richard Stallman, who goes by RMS. He was a Harvard grad who in physics, who went to work for MIT and became a software religious figurehead of sorts. The GPL is his handiwork. GPL is short for General Public License. And when you license something under the GPL, it means that it is generally in the public domain. But the GPL makes a couple of stipulations for what you do with software that is licensed under the GPL. If you make a derivative product or you make changes to a piece of GPL code, the derivative is also under the GPL. And you agree to this when you download it or grab it, that end user license agreement that you're clicking on more often than not. If it was a GPL, you agreed that you would not modify the software and keep the changes private. You're agreeing that any changes you make to it are also public domain. It's worth noting that the GPL doesn't specify that you can't make money making this software. Quite the contrary. It allows you to charge a repro fee. So Linux, although you can download all of the sources for Red Hat for free, for instance, to cite a major commercial Linux vendor, you can also pay them to download an ISO of all of them and to pay them to download an ISO of the entire operating system. And they can charge you a subscription fee to download patches for that operating system and to provide support for it. And this is, again, the primary differentiator between Red Hat Linux and CentOS. Essentially, they're the same operating system, but we are going to use CentOS because CentOS does not ask for money in trade for updates and support. But most of the software under the GPL is free. And again, Richard Stallman developed this because he was dismayed to find that a lot of the software that he bought for a lot of the components that he used in his lab were of this variety, commercial closed source software that he couldn't see, but he knew if he had the source code for it, he could make the necessary changes to make a fix as opposed to contacting the vendor every time he had a problem. So it was his own personal crusade at first that all software should be free. And beginning with that we should have a free operating system. So he coined and started this project, the GNU project. And it's worth noting, GNU is a recursive acronym. Stands for GNU's Not Unix. And you'll see this a lot too. A lot of people have repeated this. The kernel for Mac OS, for instance, is called XNU, which is Mac OS X isn't Unix also. But GNU was supposed to be an operating system, and they created a lot of GNU branded userland utilities, things like PS and LS and grep and all of these things. There are GNU versions of all of these utilities, and these GNU userland utilities are consumed by Linux distributions to make sure that they release an entire bloody operating system under the GPL. Richard Stallman, after he got a bunch of people developing all of these userland utilities, started to make a kernel, and in running with the theme and his sense of humor, the kernel was going to be called the herd with a URD, presumably to make it like the word turd, or a play on the word turd. It had to be, I would think. But it was worth noting that the herd still has not a single stable release, because somebody named Linus Torvalds came around and made a kernel, released it under the GPL, and kind of took the steam out of his product, which is why you will see Linux distros in some cases branded as GNU/Linux, because again, Linux is, like I said, just the kernel and its tool chains, and GNU is really the userland from this operating system that Richard Stallman devised or thought of in the early 1980s, but never made a working kernel for. So that's the GPL. It's also worth noting that the GPL has undergone many revisions, and most stuff out there is GPL v2, including the kernel. There has been a GPL v3. I have not read it, but a lot of people who have read it have found its terms to be slightly more onerous than the GPL v2. And notably, Linus Torvalds has declined to change the licensing for the Linux kernel from GPL v2 to v3, like a lot of software publishers have. These two licenses are pretty generally compatible with each other. Again, the GPL v3 is more restrictive. And it's worth noting this restrictiveness, this freedom, so to speak, is where you can get a lot of people really animated talking about software licensing. Because in software, it's worth asking what the definition of free really is. Is it free of cost? Is it free of charge? Does it mean that you're free to have the source and to modify it as you please? What are you able to do with that derivative product? And depending upon who you ask, you may get the answer that the GPL or the BSD license is more free, so to speak. BSD license is really short and sweet. It's like 3 clauses long. And essentially it says, this software has no warranty whatsoever. We don't, if it's broken and it doesn't work for your needs, don't call us. We don't care. I mean, they may provide some support, but essentially they're stepping out from a guarantee of support and warranty in using it. You assume your own risk when you use it. But the BSD license by omission allows you to do whatever the hell you bloody want with that piece of software, which is why a lot of BSD code has been taken and incorporated into and made a part of other commercial products, because you can do this. And again, this is why I still include BSD Unix in this class to this date. It's still vital and important because it ends up, you'll find it in a lot of embedded devices if you don't end up choosing to use it as a matter of election. I still use BSD operating systems for servers, as the case may be. I use Open for the CS574 lab. I use FreeBSD for a server because I just wasn't a Linux guy at first, but I still use them. And again, it's worth noting that the Mac is derived from free and open BSD and from this lineage. But again, the BSD license is what most people consider truly free, in that you can do whatever you want with the code. You know, again, Sony took FreeBSD and they made it the basis of their newer PlayStation products. Sega took NetBSD and made it the basis of their last console. Nokia took FreeBSD and made a line of firewalls. Checkpoint also FreeBSD. Juniper, the router company, took FreeBSD and made it into their router operating system because it's already got a great IP stack. You're going to find these BSD OSs in a lot of embedded environments because the BSD license allows you to really do anything you want with it, to modify it and make it a commercial product, and decide to license it under different terms afterwards. A lot of people are also pretty fond of saying that the GPL is free like communism is free, because nobody has any property rights for anything once something has been GPL'd. That is, aside from the original owner. The original owner can, of course, under copyright law, license a piece of software under multiple licenses for multiple use cases to multiple parties. But yeah, typically most stuff under the GPL is exclusively free and open source. And if you mod it, you are expected to make those changes public. The GPL was tested in court. It's worth noting, and this is one of the reasons that we have all of the open firmwares, the WRT open source firmwares for wireless routers. Some of you may have used DDWRT or OpenWRT. I use both of them myself here at home, and we have those operating systems out there in public because in one of the first legal tests of the GPL, Linksys is now a Cisco subsidiary, but Linksys made some of their first wireless access points using a Linux derivative, which is of course GPL'd. And again, the GPL says you take this, you make changes to it, you need to release them in public. And you could almost hear the sound of all the people in Linksys in Orange County. They're based in Orange County, or at least they were historically, all do a collective oh shit together when they realized that their bluff had just been called, so to speak, because they clearly used Linux inside the router, and then they got sued under the GPL. And because it was this first great test of the GPL, and there's so much software out there, I think it was the EFF, the Electronic Frontier Foundation, did a pro bono court case against Linksys, and Linksys lost, and they had to release all of their changes that they made to Linux to make their closed source wireless product. And again, all these DDWRT and OpenWRT are derivatives of that open source Linksys firmware because Linksys lost that lawsuit about 15 or 20 years ago. Some BSD clauses licenses have an advertising clause where you display a copyright notice. The simple or short BSD license doesn't have this clause. The MIT license is very similar to the BSD license, but again, essentially these licenses are legal contracts that define what you can and cannot do with a piece of software. You get to set those terms when you license that software, whether you're releasing it publicly for download or you're selling it to somebody. And so you can freely define these terms in a legalese word salad. But Apache and Apple, there's a Creative Commons license. There are all kinds of open source licenses. Apple's is called the APSL. Apache's is just called the Apache license. Again, there's a Creative Commons license. But you get the idea here. Again, I provide this historically so that you know about it, so that when you run into it at some point in your professional careers, licensing will almost certainly impact some kind of software selection, or whether you pull a tool off the shelf and use it or build on top of it. So it's totally worthy of addressing right now. Neil, I see your question. I use Mac versus Windows because I'm not a Microsoft bigot anymore, but I still think Windows is built like a house of cards. And Windows 10 is the first Windows that doesn't make me feel like I'm bathing in acid while I'm using it. It's just a poor ass excuse for an operating system that I tolerate for video games sometimes. I'm a Unix guy through and through. I had a Mac and a Sun when I was on your side of the classroom. I don't hate Windows anymore, though. I still think it's built like crap. What's the only reason to use what, Will? Video games for Windows? No, sometimes it's just the right tool for the right job. And since I brought it up, this is how I've evolved over time. We tend to hate things and sneeze at things that we don't know as well, or as opposed to speaking from a place of experience. I can still speak from a place of experience in calling Windows unintuitive and ugly and built like a house of cards. When I go through whether or not we make it there today to the file system layout of Unix, your opinion, it is opinion. It is an opinion, and I'm going to caveat it as such. I think the Unix file system layout is a thing of beauty that makes perfect sense. Windows is still so stuck in 8.3 land, and with those 50,000 files that you've got under C:\Windows\system32, that you really can't sanely find anything that you need. No, there are multiple reasons to use Windows. Windows does do some things a whole lot better. What you can do with a Windows authentication domain, notably, you cannot easily do with any Unix out of the box like Windows. And Hinton, yes, I do, but it's kind of off topic. Let's say, ask me that one during question and answer time at the end. I'm going to try to pick up the pace here for the last 45 or 50 minutes here. So again, let's talk about, move on to the next topic. Kernel space versus libraries versus userland. In CS570, you may have seen this diagram, at least when Guy Leonard taught it to me, and I know he still teaches 570 today. He drew almost like a target with concentric circles going out in layers. And in the center was the kernel. The kernel is the core of the operating system. It's the first thing, well, not the first thing, as we'll see when we talk about booting, but the first thing of substance that is loaded off the hard disk to really boot the operating system. And the kernel is by design for historical purposes. Again, like I said, I'm going to add to these notes here. It's a very small piece of code, both to ensure its efficiency and speed, and because memory has historically not always been so cheap as it is today. The kernel is in every, this is worth writing down. The kernel is in every virtual memory space for every process. It's exposed to everything. We never can swap the kernel out when using virtual memory. So there are a variety of reasons that still to this day, we want it to be compact as possible. Really, it is the barest minimum amount of things that we can load to load up the OS and bring it up by its bootstraps, so to speak, a reference to how you pull on some tall boots, physical shoes, and why we still call the process of starting up a computer booting. But it's everything at the very core of the operating system. Device drivers, the concept of the file system. We'll have our network stack here. You're going to have virtual memories implementation here. The process tables and the scheduler are effectively a part of kernel memory. If you really look at Unix from a 10,000 foot level, from a software developer's point of view, everything that runs on a Unix, every piece of software that runs on a Unix is really a client to and a dream within the kernel, so to speak. A data structure for the kernel with some code that gets run from time to time. Liliana, who called it the nucleus? Leonard did. It does make sense. It's worth noting that you will hear in some cases, and you may have already heard this in 570, those of you who have it, you may hear a microkernel versus a macrokernel, which is also sometimes called a monolithic kernel. And this is a school of how you develop the kernel, needless to say. Because over time, again, note how we put device drivers in here. Let's go ahead and separate this onto its own line. Device drivers. In fact, let's go ahead and put it last, because it's really the one that created this whole debate. Historically, when you wanted to build a new kernel, you had to rebuild it from source or from object files. And in order to make a device driver, you had to have a lot of the kernel headers exposed to you via special kind of licensing agreement. Of course, although some things are commercial closed source, if you are a developer, a partner, needless to say, you could, from Sun back in the day, get a license for all of Solaris if you paid enough and had enough cause that they would license it to you under terms where you got to see the source. Well, then there are user space computers. We add devices to our computers like all the time, right? Especially, you know, nowadays, zoom ahead to the 21st century. And since the iMac came out at the beginning of it, now everybody finally uses USB. Throughout most of the 20th century, everybody wondered what the hell those USB ports were on the back of PCs, and nobody ever used them until the iMac came out. But we need to plug in, we want to add device drivers and devices to our computers all the time in places where we don't want our users to have to recompile a kernel in order to add a device to their computer. So virtually all modern OSs use a hybrid model of sorts where they're incorporating monolithically most of this other stuff, so to speak, but they allow for what a microkernel does, allows kernel modules to be loaded after boot. And most OSs have this capability so that we can add a device driver, not only without rebuilding a kernel, but also without rebooting the computer as well, hopefully. Just because you plug in a device doesn't mean you want to reboot it. I mean, still to this day with Windows, we have to do so a lot, especially even recently, but it never meant that this was attractive behavior. And the second layer of this, that nucleus diagram, or that target, as the case may be, I call it target because it looks like a target and our OS is a target in the security class. At the second layer are these libraries. And libraries are all of the programmer's interfaces. It's funny. In Windows, we have this concept that DLLs have an entry point like a program and can be run in some cases. And I still bristle at that a little bit because libraries, as I know them and as I've always known them, are just programmers' interfaces for how to do these things that we want to do repeatedly, that are common tasks that we want to do on every kind of computer as well, and how to do them on the local system so that we use a library function and make good reuse of that code as opposed to rebuilding the wheel on every computer that we implement it. There are a number of reasons for this, including and especially like if we find a flaw in a library function for doing X, and all of these binaries all do that thing, that X, with our function in a library, we only have to make that fix in one place in that shared library. So a lot of our common operating systems facilities have hooks or programming interfaces here in these APIs, including logging and errors and printing things to terminal and SSH and encryption. And again, a lot of common underlying facilities that don't necessarily do end user functions that aren't the applications themselves, but plumb them with capabilities, if that makes sense. We'll see this stuff a lot. It looks increasingly like from time constraints, like we are not going to make it all the way to the file system tree. But long story short, you will see this stuff in lib directories on all of your Unix and Unix alike operating systems. For instance, on OpenBSD, we have user lib. I'm going to pipe it in some more. You can see a lot of these object files. You know these from compilation. Again, these are common objects. Think of all these libraries as shared object files, because that is actually what most of the extension .so here specifically means. So on a Unix, a .a is an archive. And this is what we also called sometimes a static library. When we can take a static library and we pull an entire copy of its code into a binary when we compile it. When we want to do dynamic linking, and it's worth noting dynamic linking was something first invented in Unix. The idea here is, hey, we have a lot of things, a lot of processors are using the C++ shared object because they're all coded in C++. This right here on OpenBSD is the C++ runtime library. And the idea with this shared object, which is dynamically linked, is that we can load it into RAM once, and we can expose it like the kernel in every process's address space, but we're able to save on memory because we only need one copy of this library loaded up into memory at any point in time. This is just a collection of routines that other stuff uses. Make sense? Chime up if not. Feel free to raise hands anytime. All right. So that is what these are again here in user lib on OpenBSD. This is a statically linked, a statically linked archive library. Essentially, this is going to be the same stuff as this, but this is statically linked, the .so. You'll see how .so and .a are used pretty exclusively on virtually every Unix and Unix alike. Here on Solaris, on an AT&T-ish one, you will see, wow. User lib has changed a lot, but you can see some of these .sos are in here. It does use this. There we go. Lib starts it. So here they all are. You can see mostly dynamically linked stuff here. Linux, it tends to put a lot of stuff in lib or lib64. Again, I said you get different paths for different bitness of binaries on stuff in Linux, lib64. And you can see, let's dereference that folder by putting the slash at the end. Since you can see it was a symbolic link. And you can see some more symbolic links, but you can see Linux again is using .sos. And we'll probably, we might see a .a, not many .a's. Again, most stuff will typically use .so. For those of you who have Macs, though, you may notice if you look in user lib, Macs do use .a. They definitely do. But with their dynamic libraries, they use the extension dylib. And this is because the Mac uses a different binary format. For instance, user lib C++. Nope. File lib 64 lib C++. Nope. Here we go. Let's just use the C lib instead of the C++ lib, and you'll see that this is a new Linux dynamically linked. You'll see that this file command again is very useful. And it shows that it's ELF format binary, 64-bit LSB shared object. Macs gained their heritage from the company Next, which had an operating system that always ran on multiple CPU architectures. So again, like I showed you with my text converting commands in my home directory, again, the binary format on a Mac is this Mach-O format from the Mach kernel that allows a binary to have multiple CPU architectures supported within the same file. And it was pretty neat there for a while. Apple just announced a couple weeks ago that it was going to transition operating systems for like the third or fourth time in the company's history. And there for a little while in the middle of the 2000s, the aughts, when they announced their transition from PowerPC to Intel, you had one CD-ROM that you could use to install the same operating system on both a PowerPC computer and an Intel-based computer. And you could take the hard disk out of either a PowerPC or an Intel Mac for that period of time in between Tiger and Leopard 10.4 and 10.5 and move it to a computer running the opposite CPU architecture or the other CPU architecture, because every binary, including the kernel, had code for both CPU architectures. That same hard disk would boot both computers and just run. It was pretty cool. So we're about to have the same thing again, clearly, with Intel and ARM binaries as Apple makes its next CPU transition, but this again is why you have the different ending here, because it's not a .so file on Mac. You may have multiple CPU architectures like userlib, libcrypto. Let's see what libcrypto says here. And again, just recently, one of the big changes in Catalina, which I'm running, was to remove all but 32-bit support. So this is not too surprising that built-in system libraries no longer have the 32-bit Intel object. Okay, so we talked about the kernel, we talked about libraries which sit on top of it but aren't actual usable functions. Then there is what we call userland, and userland are the things that are actually directly invoked, called from a command line, called by a user, runnable to do actual things, with the idea of consuming as much kernel and library code as possible. But for the most part, again, everything you use and actually interact with, unless you're programming, is going to be something here in userland when you're interactively using the operating system. In Unix, dynamically linked libraries do not run like on Windows. Did I keep everybody with me here through that concept? Raised hands, going once, going twice. Moving on to the next topic. Jeffrey, looks like you raised your hand and then like you maybe dropped it because I don't see you with a hand raised anymore. Mr. Hollis, I've invited you to unmute. Do you have a question, sir? Take two. I accidentally muted you right after you unmuted yourself.
I was just saying I understood, my bad.
All good. I'll take that, man. You don't have a bunch of faces, so feedback is hard to come by. I want to make sure I'm not losing you. Usually in class, I'm walking around through the class, I'm looking at all of you, and I'm telling who's dozed off and who I've kept and who looks confused. And I talk to the people who are confused in class, or I try to. Anyways, okay, so abstractions. We kind of covered this in the first lecture, but again, remember, everything in Unix is a file or a process. And again, we've kind of blurred this line as well. I wanted to show you, excuse me, the proc file system on Mac OS. I know it used to be there in earlier versions. It's not anymore. It's worth noting that it doesn't show up in DF output, but if we do mount pipe grep proc, it shows us that we have a proc file system. And you can see, as opposed to, let's do mount pipe grep SDA1. So you can see in CentOS, the default file system is XFS. And that was used here for my actual file system. But this proc file system reports a type proc because it's a virtual file system plumbed by code. And if we do an ls/proc, you see a bunch of things that you can do with the proc file system as, excuse me, it has been abstracted on Linux. Again, the idea here is, I personally don't use this much, so I don't have any great use cases to pull from, but you can use file system operation or file operation commands on this process tree to do common tasks. It's worth noting, one thing I do with some regularity is cat proc CPU info. And on Linux, this is a great way to find out details of your actual CPU, for instance. But again, these numbers here, I did ls, not with a long output format here. And these are the process ID numbers of running processes. Okay. As funny, processes on the command line. We already kind of covered a lot of this. We get to kill a lot of this. So semicolon, we did it, check. Ampersand, we did it, check. Jobs command, we did it, check. We did PS. It's worth noting. Top. Top is a great way. This is one of those commands that really makes use of that, excuse me, killer sweet tart over here. That really makes use of those terminal settings, because you can see it's using reverse text here, boldface, and it's dynamically redrawing the screen based upon a default polling interval. But the top command typically by default will rank the top CPU consumers amongst all processes and showing you what's going on your computer. And it also kind of gives you a handy dashboard of CPU utilization, the number of processes, your uptime and general load, and some dials on memory and virtual memory. But top is a real neat command for looking at what is going on inside your computer, so long as it is covered here and I did not lick it earlier. The life cycle of a process, at long last. Had lots to talk about today, and again, we're gonna call it a night, or at least call it Q&A time in like 25 minutes here. But let's get to some of these handouts. And the life cycle of a process. So a process usually begins life again with a fork. And here, these are the process state names that will oftentimes show up in some of the APIs or some of the various outputs of PS. But a newly forked process comes in and gets itself ready to run and gets a little bit of CPU time. And it hops, yes, indeed, iconic Carroll course reader diagram. This is total Dr. John Carroll. And I have to give credit here. This, I think, still came out from the from my original thing back in 1990 something, because this is still the same. A process goes into run mode immediately, and it vacillates between running in user mode and running in kernel mode, depending upon which code is being run. Again, the kernel is in every space, and we elevate privileges to run into code in libraries and into code in the kernel as required, and bounce back and forth via various interrupts and system calls. We get shares of the CPU, and we vacillate between sleeping and running, as it shows here in the middle line. And we may be either ready or sleeping and become swapped out because our computer is running low on physical wired memory. When we're swapped out, that means that pages of RAM have been written out to a slower storage medium like a disk space. And we'll cover, when we do file system layout, how disk space is laid out to allow for this, because there are a number of different ways. But long story short, again, processes are all always born with a fork. The parent process always cloned itself, determined which one was the child, and then ran the new command or whatever they were supposed to do in that child process. Sometimes they finish what they're doing and they execute the exit call, or the exit command if it's a shell. Sometimes we kill them like we saw earlier. This is one way of receiving a system call or an interrupt. And sometimes they fail to completely get cleaned up from, and they become a zombie in the process table, where we have some modicum of unreclaimable RAM or other resources. Maybe just the process table listing. Maybe the kernel just isn't able to validate that it actually stopped running, but for whatever reason, when we have a process that we cannot kill, die, or forcibly remove from the process table, it is called a zombie. It is an undead process. We looked plenty already at the output of PS, so I think we've got all of this. And I'm not going to rehash. Please feel free to object now in the chat window, and I will pay some more attention to it. But every process has a nice value associated with it, and this is how we do prioritization. Again, one of the functions of the kernel is to do scheduling. The scheduling is done with a priority queue, not just a queue. Some processes are more important than others and get more time, get more priority for slices of the CPU. And if we have root abilities on Unix, we can reduce a process's nice value, meaning that we can say it is more important for allocating CPU time to. But we can only do that if we're root. No matter who we are, we can use the renice command to reduce our prioritization. We are always allowed to reduce our process's queuing capabilities, our queue priority, even if we are not root. And again, the kill command is one API for sending signals to processes. It's the best, most widely implemented. It's the one we all use on pretty much every bloody Unix. And even though kill is the name of one signal, somehow kill became the name of the command that we use to send a signal. So even if we're not telling a process to die, we use the kill command to send a signal. And let's look at the signal header file. I'm going to look for it in a few common places on a few OSs. This is, again, that Solaris derivative VM. Let's look at more user includes sys signal.h. Here on OpenBSD, it is where it's supposed to be, and you can see the names of the signals because, again, these are defined in header files. If we with the kill command, we can either provide some of their shortcuts, for instance, hup or int or quit. Hang up is often sent to a process to tell it to quit or reload. With a lot of services, if we send the service a hang up, it will reread its configuration file and start over. And it's really useful to know in some cases which processes will use this, because we can just, for instance, named is one of them. When you set up your name server, a really easy way to restart your name server is just to send it a kill-hup. Restart and reparse config files with kill-hup. Quit, of course, means quit. Kill is also known as -9, so you'll hear kill-9 all the time because 9 is the number for the kill signal, which cannot be caught or ignored. Pretty much, you're not signaling the actual process here. You're signaling the kernel, kill this process dead immediately, reclaim all of its stuff. This is not actually sent to the process. But you'll see that there are a number of these. It's worth saying there's a stop command. You can do a kill-stop, which means use no more CPU time until later. And then there's a signal called cont, which is continue. Begin work again. So pretty generally, you can send a process a signal that says stop right there. and then you can tell it to go again. And if you wanted to play red light, green light with your processes, you totally could on the command line with, again, the kill command and some of these signals. And of course, you can define custom ones because this is an API. As you can see, that's cooked into the operating system, implemented in a command and a library, and so on. Any questions on this? Watching for raised hands. Dun, 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 dun. I see one. Neil, speak.
Hey, are we able to get those diagrams? Because I see you had a whole bunch of them. Are you going to be able to put those on the website or not?
Neil, didn't I say that I would post these after lecture, sir?
I didn't hear you. So that's what I'm asking again.
I believe I said it twice or 3 times.
Okay, I missed it then. Thank you.
Yep. I definitely shall. Immediately following whether or not I went through them, I'm going to post them all. And we'll go through the rest later because I ask, and I'm going to invite you to ask questions because it looks like this is a logical break time. The rest of the stuff that I'd hope to get into tonight is all about file system layout, and then boot. And we really need to cover file system to cover boot. So I think for time considerations, we've already been 3.5 hours, inclusive of the intermission. I think it's a good time to call it a night and invite Q&A time and your questions. Steve Hankey, I see your question in chat. Would stop or continue have adverse reactions to the process? I think it depends on the process. And I believe on a lot of operating systems, these are actually implemented within the kernel. That you're actually, like with the kill signal, saying, hey, kernel, don't give this process CPU time. I have never seen it have an adverse reaction to a process that I so signaled, but needless to say, you can send a stop signal to a process that's doing some time sensitive IO, and when you tell it to continue, if the input stream isn't still there, it may freak out and not operate as expected, depending upon the way you passed input into it. Did that answer your question? Yes, you're welcome, sir. Any other questions? You do have a question, Steve? Do you want me to unmute you again? Ah, okay. Anybody else? All right, folks. Oh, I see Martin Phillip. I was about to say, let's call it a night. Brandon, raise your hand next. Good question. Martin Phillip, you're up.
I think I have my 2 servers up and running. Just to like check, should I just set up a like a custom cron job and see if it sends me an email? Like it does do at 9:45.
Sure. I absolutely encourage you to tinker with things, set up additional cron jobs, and customize stuff. Just note that the ones that I have asked you to set up are the ones that I'm going to grade you on. So you can, by all means, add additional stuff, but don't take out the one. I don't recommend you take out stuff that I've asked you to configure, because stuff I have asked you to set up, again, is stuff I will be grading you on later.
All right, thanks.
Yes, sir. Good question. Much appreciated. Anybody else? Brandon Castor, you're the next bidder on The Price is Right.
Hey Peter, I have a question. So is there a command to like restart a process, or would it be better to like stop the process, kill it, and like start the process again?
So that is a neat open-ended question, because the answer is like the answer to a lot of questions is it depends. I need to know more about your use case. In some cases, the best way to restart a command is just to run it over again. Depending upon what it is, that may be as easy as hitting the up arrow and return in your shell to rerun the last command. But if it's something like a service, like I told you, sometimes a lot of services implement a handler for the hang up signal that makes them restart themselves. But again, they have to implement that. So it depends upon the piece of software and the use case. I can't give you one single answer that fits all sizes, as the expression goes. Does that make sense?
Yeah, it makes sense. Yeah, I noticed that on lab 2, I was able to restart a service, but I was wondering if I have a process running like nothing comes out of the top of my head, but like if I start a process and I start that same process again, would it restart it, or just like start that same process on like the same memory point?
It won't. You almost never get something at the same memory point because you don't generally get to choose where in memory your stuff is. In modern operating systems, we expect all code to be position independent. That is, we expect it to be reloaded and linked. Shit, and that would have been, pardon my French, a good place to go today. Loader, linker. I'll make sure we go there next. You don't get to choose where something loads and ran because all of memory is virtualized by design. So again, it depends on your use case.
Oh, okay. Thanks.
Yeah, if you want to ask me about a more specific one, I don't mind, and feel free to raise your hand again, sir. But does anybody else have any other questions? Okay, so again, homework is read Nemeth 1 to 5. Note that lab 3 coming shortly. Lab time tomorrow, Tuesday, 7/21. Obata, if you have to skip or you just want to, I'm fine with it. Sorry for the surprise. I just realized that I wanted to do that to make up for lost time right before this class started. And there will probably be a lab 1v4, sadly, coming shortly because I've already made a couple corrections that I haven't publicly released, and a couple of people notified me about more stuff within the last 24 hours that I have yet to respond to. So I'm going to try to catch up those emails. And again, if you have the time and you are available, I'm standing up this extra time tomorrow night to provide support and see if we can get some of you who are blocked unblocked. Again, probably not by handing you the answer, but by trying to make you think. Anybody got any other questions? I see you, Mr. Aziz. Speak and be heard.
I just have a question on lab 2. Is that fine?
Yeah, absolutely. Anything is fair game right now.
So on step 13, I have to do a step that installs bash. And when I try to do that, I not down for a bunch of places. And then at the end, it says, like it stops the ports.
You said step 13?
Yeah.
And it does what?
So like towards the end, it just says make and then parentheses 3 and then stop in user ports print text.
Ah, you ran into a build error. So again, you will note I just highlighted stuff in red there for you, sir. Make sure you read the whole step. Because when an error happens, you need to scroll up and find the first error. Everything that happens after it is often resulting. But I need you to find the root cause. You've just described for me a build error, building a port from source. And
So the root error was like, says bash 5.0.18 depends on executable BISN not found.
I guarantee there was an error before that. That isn't an error. Typically, it's going to go build that missing dependency when it discovers a dependency is missing. I want you to send me a screenshot. And again, if you haven't found the root error and Googled for it or DuckDuckGo'd for it so that Google wasn't able to turn your thinking into money, that you do so before you send me a screenshot. Understood?
Yeah.
Cool. Again, this ability to scroll back is why we use SSH a lot of the time, because if you're using the console, you may not be able to scroll back. But yeah, kind of covered this. Thank you, sir. Next batter up for bids, Alan Sewer. Is it Sewer or Sir?
Sir.
Thank you, sir. Hit me. What's your question?
Hi, I'm on a lab 2 and I'm on number number 23. And when I do the sudo etc/rc.d send mail restart command, I get the no local or I just had it. Sorry, I get the no local mailer defined, but I thought we defined it in the step where we added to freebsd.mc the 3 prior lines.
Indeed. Guess what that means, Alan?
I typed it in wrong.
That's right, Alan.
Okay. All right, perfect. All right, thank you.
Remember that comment that I made about cutting and pasting or copying and pasting out of PDFs and
Yeah.
documents?
Mm-hmm.
A lot of the things that I create here, you know, I try to catch every case where it changes a quotation mark to a frilly one. You can see the comments here and how I've managed to stop it.
Yeah.
But yeah, you kind of generally want to recreate what I have as opposed to copying and pasting as a general operating procedure. And you want to look around at the text around that in that config file that you were editing, because it will provide examples for the syntax.
Okay, perfect.
That you can use, okay?
All right, got it. Thank you.
Thank you. You are welcome, sir. Anybody else? Quick show of hands. Mr. Lee, I'm going to, you may unmute yourself. Please be heard. Thong Lee.
Hello, Peter.
Hello, sir.
Hi, I'm having trouble. I already set up my Thunderbird, but I'm having trouble sending mail from my OpenBSD machine. And when I read the log, I get, can I send you a picture or can I share the screen?
I don't want you to share the screen right now. I'd really rather you sent me a shell transcript or a screenshot. And if you're sending, again, if you're sending me a screenshot of an error message and you haven't Googled it, expect me to make a snarky reply.
Okay, I'm fine with that. How can I send you a screenshot?
Yeah, send it to me via email.
Oh, okay. I already sent you an email.
Okay, like I alluded to, I know I have a backlog of emails that I have to answer. Like I said earlier in lecture, I work a regular full-time job by day. This is my favorite job, but this is my side job.
Okay, so would you like to see the screenshot in that email or?
No, not right now. It's in my inbox and I'll get to it later.
Okay.
Do you have another question?
Oh, no, that would be it.
Okay. Nathan Ware. Speak and be heard, sir.
Hi, Peter.
Hi.
I had a quick question on the second to last step of Lab 1. It is asking us to point our host computer's operating system towards our OpenBSD's DNS virtual machine.
Correct.
And I wanted to know if you wanted us to, like, I'm on Windows, point our Windows machine, or if I can use the WSL Linux distribution that I downloaded onto Windows and just point that at the OpenBSD.
I'm fine with either. Again, the point of this step and this exercise is to get you to test and exercise that name server and make sure that it works for other hosts besides itself, and that it will provide names for everything on the internet.
Okay, great. Thank
You
you.
want it to be a functioning, local, private, recursing name server so that you can offer internet service to all of your VMs and have it have them all find the places they want to get software.
Okay,
So,
perfect.
however you test it, I don't care. Again, I'm telling you to undo that, and we're going to work around it. I forget if it's at the end of lab. Yeah, here we go. It's at the end of lab 2 that we work around this and create a local hosts file on your host operating system so that you can see all your VMs. Because I don't want you to have to do that back and forth to be able to go into your VMs by name.
Yeah, thank you. I was worried about that.
Yeah, indeed. No, there's still a local hosts file on every computer to override specific lookups, and this is the right way to go for a use case like this one. I do it on my own. For instance, you can see grep cs470.local and Etsy hosts here on my Mac, and guess what I've got there?
A whole list of them, yeah.
Yes, indeed. No, good question. Anything else, sir?
No, that's everything. Thank you.
Yep. All right. Lower hand. I did not mean to ask you to unmute again, Nathan. Neil, I saw you had your hand raised. No question anymore? Well, lab session, okay. Asked to unmute. Speak and be heard, sir.
Yeah, basically is the lab session specifically to lab 1, 2, both new techniques, commands for the labs, or?
No, I'm not going to lecture, so I'm not going to teach you any new techniques or any new anything. It's really just going to be a support session in office hours so that if you're blocked and you've really done some web research and you're still confused and you got good questions, that you can get support and get unblocked.
Understand. Thank you.
But anything is fair game.
Yeah.
Anything CS470 related.
Yeah, right. I mean, I'm done with lab 1. I'm going to start lab 2 now, and I don't know if but I just noticed that you have a version 2 to lab 2, right, on the website?
Yes, sir.
Yeah.
You can count on this happening repeatedly. This is what I'll do, and in order to cut down on the number of announcements that I make, I'm not going to tell you every time that I make an errata. The way I do it is I just change the file name slightly so you realize, oh, there's a change. You look back at that folder on that slag heap web server of mine and you see that you're looking at the next version, and I clearly print in the top header what the changes are since the last version.
Yeah, that was useful in lab 1.
I will always do that so that you grab a new one and you don't have to go on a hunting expedition to know what changed.
Gotcha. Thank you.
I think it's only polite. All right, Z, you're up.
Oh, hey, Peter. My question. Oh, hey. What time is it going to be? The same time for the lab tomorrow, like 6?
No, I said 5:30 to like 7:30.
Oh, okay. That
I believe
was
I put
it.
that in my notes. And again, the notes will be online shortly.
Thank you.
Yeah, of course. Totally perfectly fair question. I said 5:30 to 7:30. And I'm not gonna look at my calendar while I'm sharing and recording my screen, but I'm gonna make sure that works and I will make a proper announcement. But again, there's not gonna be any hard lecture there. It's just gonna be support. It won't be recorded. So if you can't make it at 5:30, don't worry. I'm just setting off a block of hours to help people. Any other questions? Going once, going twice. And again, on Wednesday, we'll get into file system concepts and booting. And I'll see some of you tomorrow for some support. Have a good rest of your evening. And I hope I didn't suck.